Welcome to this comprehensive course on building robust desktop applications using Electron, React, and Typescript. Throughout this course, you'll learn everything from setting up your development environment to implementing advanced features like data visualization, secure communication, and custom window frames, all while ensuring a seamless user experience. Niklas Zimmermann developed this course.
Hey there, I'm Niklas Zimmermann. I'm a full-time software engineer from Germany and I absolutely love web development, which is why I'm so excited that there's stuff like Electron that allows me to combine my web dev and my Node.js skills into one singular cross-platform app that will run on Windows, Mac, and Linux. And we're going to build an app like this right here today, which is going to be a resource manager inspired by the Windows Task Manager Performance tab. So basically some pretty graphs about your CPU, RAM, and storage usage. But before we'll do that, let's take a look at how Electron actually works and why you might want to use it. Alright, so what actually is Electron? Well, as I already mentioned, it's a tool to build cross-platform desktop apps with JavaScript, HTML, and CSS, or alternatively something like React to replace these three things. And some popular apps that already use Electron are, for example, Discord or Visual Studio Code, which you probably already know that it exists. All right, so how does Electron actually do all of this? Well, let's try to visualize an Electron app. So this big blue box is going to be our app, and we're of course going to need to have some way to open up a window. So Electron calls these things browser windows. So actually a window of a bundled browser that can display our HTML, CSS, and JavaScript. And Electron creates this window because it actually bundles a whole version of Chromium. So basically every time you download Discord, VS Code, or whatever Electron app, you will actually download a whole Chromium browser that Electron controls under the hood to display and hide windows and interact with them. So basically what this browser window does is just one window of a Chromium browser that you downloaded with your Electron app. But of course, rendering isn't enough. We also want some information about the system, like for example, how much RAM we're using. And the way we can do that is using the main Electron process. And this main process is basically just a Node.js app. So you can imagine that when you start your Electron app, this main process will boot up and it will do some of the tasks that it's designed to do. The main task, of course, in the beginning is creating windows / interacting with Electron. So basically interacting with the Electron lifetime, opening windows, reacting to windows being closed, closing windows itself, whatever you need to do, all of this can be done, and you can even create multiple windows. So you could also have like 3 of these if you need it. In our case, we just need 1, but it is possible. Then again, Electron can of course do much more. For example, it can interact with system APIs. So system APIs could be something like the system tray, to create icons like the ones you see up here on the right on macOS or down on the bottom right in the taskbar of Windows systems. And the most important part for our use case is of course just a Node app. So it can use Node modules. So basically most of the things hosted on NPM and of course the built-in Node stuff as well. So the FS module, the OS module, or even something like Express if you wanted your Electron app to also host a web server for whatever reason or whatever. In our case, we're going to use some helper libraries to get more information about our system, like the memory usage, for example, but most of this could also be used using Node standard libraries. But what's important right here is these are separate processes. So you can imagine that there's basically a thin line between the two that separates them from each other. So this guy can't use code from this guy and vice versa. So how can I actually get data from and to the Electron app using the browser window? Well, there's actually one thing in between these two, or multiple things, but mainly one thing. And this is the IPC event bus, which is basically a third really, really tiny process that allows both the main process and the window processes to publish events under a certain name with some data, and then listen to these events to basically get some data back. So you could imagine that maybe the window publishes, hey, I want to delete object number 42. And then the main process tells every window, hey, entity 42 was deleted. Please update your UI so that it isn't displayed anymore. Stuff like that. And this is inherently how these two different processes can communicate with each other. And now that we understand how Electron does all of this, let's now actually get into what technologies we're actually going to be using to, first of all, develop our app and then actually turn it into an EXE. Because Electron actually can't turn stuff into EXEs, DMGs, MSIs, app images, whatever. You need an extra tool for that. So let's try to visualize our tech stack. So down on the bottom, both for the front end and for the back end, we're going to be using Typescript. Then we'll separate the back end and the front end into two separate stacks, basically. So right here, we've of course got Electron. And on the other side, we've got React. Now the question is, how are we actually going to turn all of this into a fully fledged Electron app? Well, first of all, we need to bundle our React app to actually have HTML files in the end. And for that, we're going to be using Vite, which is just a bundler that allows us to really easily and effectively create HTML out of our React that is fast and small, which is really helpful for our use case. And then we, of course, also need to bundle basically all of this into a finished Electron app. And for that, we are actually going to use Electron-Builder, which is one of many tools that can be used to basically convert your normally Node.js Electron app into a fully fledged EXE, app image, whatever you need for your specific system needs. So you could create an installer, you could create a portable app, whatever your users want to use. And this is what Electron-Builder does. So basically we can write our Electron and React app in TypeScript. We can take the React app, turn it into HTML using Vite, embed that into Electron, and then build all of that using Electron-Builder to, in the end, have a runnable project. And honestly, don't worry if you don't understand all of this yet. Our next step will be building this little foundation right here that will basically set up our React app, build it into HTML, embed it into our Electron process, and then building this Electron process into an app that can run on your system. So an EXE, a DMG, or an app image, depending on what system you're using. And once we've built this, all of this should be a lot clearer. And of course, you can just jump back after building this to this part of the course if you still don't understand everything and want to try to understand it better using your new knowledge that you've gained by developing the actual thing. And after we've developed this foundation, we will of course get into actually developing the stuff we need for the resource manager and also doing some developer experience improvements. But before we start, I would like to add one little disclaimer right here, which is that your operating system will most likely show you one of these warnings when you try to open the build app we're going to create now, which basically tells you that the app wasn't created by a trusted developer. And that is the case because for the operating to actually trust you as the developer, you would need to add a code signing certificate to your app. And this is something you would need to purchase. Your app will still open just fine when the user just clicks, yeah, I trust this app, I accept this. And many production apps, especially open source ones, actually do that. But I just wanted to mention this because I don't want to add anything into this course that you need to pay for. So we will not go into code signing certificates because those can only be obtained with money, which is something that I just don't want to add into this course because depending on how you get it and what operating system you're targeting, the process would differ anyways. So just look up the process that you need for your users if you want this warning to disappear. And yeah, if you just don't care, then that's even better. Then you can just follow this course and everything will be just fine. And now that we're in our IDE, we can actually start by creating our UI first. So let's run npm create vite dot in an empty directory. So the dot just says I want to create our Vite project right in the directory I'm currently in. And then we'll choose React because we of course want the React project in TypeScript. And now we just npm install. This shouldn't take up much time, so let's just talk over it real quick. As you can see, the files were already created right here. And now we've got our node modules and we can hit npm run dev to actually start our project. Now if we just control click onto this link right here, we can see here is our Vite and React project. But we might want to optimize this a bit because right now everything is directly in the source directory. But of course, we'll also have some Electron code, which will also live in the source directory. So let's try to split this up a bit by creating a UI folder in here and basically moving everything that's currently in the source directory into that UI folder. Now, just doing this will of course not work yet because Vite needs to know where our code is now. So let's just head into the index.html, which is basically the entry point for Vite to know where all your files are. And here we can see we've got a script tag that references source main.tsx. And of course, this needs to be source/UI/main.tsx now. And now if you just hit npm run dev again, we should be able to see that everything is still working just fine. But of course, we've also got this public folder right here, which we don't really need right now either, because we're not going to have a fav icon or whatever if we basically embed our app inside of a desktop app. So let's just get rid of this thing right now by removing it, and also heading into the app.tsx right now because it also references it, removing this A inside of this. And now if we just look into our app again, we should be able to see that our Vite app is still fully functional, even though we of course removed the fav icon and this icon right here. Now let's also change some stuff about the build, because if I just run npm run build right now, we should be able to see that it creates a dist directory that contains all of our output. So basically the finished HTML and JavaScript. This is good in some ways, but for our use case, it isn't as good because Electron-Builder will also create a dist directory. So these will conflict, which we don't really want. So let's just change the Vite config a bit more by saying build, and our build will have an out dir. So basically, where do I want to put my finished output? And this will just be dist-react, just so we know where our code is. And now let's just quickly remove the current dist directory, run npm run build again. And now we should be able to see that dist-react is created, and it still contains all of this normal code right here. Of course, right now it's actually tracked by Git, which you don't really want. So let's also head into the git ignore and add dist-react into the ignored folders, just so you never commit it, because that wouldn't really make sense. And to now combine this UI with our Electron app, we of course need to first of all install Electron. So let's just run npm install --save dev Electron. We can actually install Electron as a dev dependency because it isn't needed in the final bundle of our app, so the exe or whatever. It is only needed to build it. So even though we will be importing stuff from Electron, it isn't actually required to install it as a normal dependency. A dev dependency is plenty. And do also make sure that you set type module in your package.json. This should be set automatically by Vite, but sometimes it isn't for specific Vite versions. So just make sure that it is set, because otherwise we can't use ES module syntax inside of our Electron code, which we will need to do. And now let's actually get into configuring our Electron app. So let's create a new folder inside of our source directory called Electron. And in here, we'll add a new file called main.js. We will turn this into Typescript later on, but for now, JavaScript is easier. And here we can just import from Electron. And we'll need two things. First of all, the app and the browser window. And here what we can do is basically interact with the app. So as soon as we import it, Electron will do all of its magic to basically create an app that we can interact with. And here we can say app.on, so waiting for an event on the app. And we'll say once the app is ready, we want to run this arrow function. And in here we can say, okay, the app is ready now, let's create a window. And that window will be our main window, and it is a new browser window. This browser window can be configured in many ways, so we can set stuff like width or whatever. All of this isn't required for now, we'll get into it later. So for now, we'll just add an empty config object in here and leave it at that. And then we can just say main window.load file. And the file that we are going to load is of course our index.html file inside of the dist-react directory. So you can imagine that people will have this project in different directories on their computer. Because once you distribute it, you can't be sure that it's under whatever directory your code is under. It definitely won't be. So people could have it under program files on Windows or applications on a Mac, or maybe even in the downloads folder if you distribute it using an exe with nothing else. So you need some way to know where your project is currently running from. And the app object actually gives you a helper for that, which is called app.getAppPath. And now we of course just need to append /dist-react/index.html to this, and everything is fine, right? Well, not actually, because these slashes only work on Mac and Linux, while Windows requires backslashes for paths. But we don't need to do this ourselves, because Node actually includes a nice module called path. So you don't need to install this because it's already included in the standard library set. And what it can do is do all of this magic for you. So you can just run path.join, and we can just say, I want to join our app path with /dist-react/index.html. And now we of course need a way to run this as well, right? So let's try to configure that as well by heading into our package.json and first of all telling it where our main script is. So this main attribute is basically telling Electron which script to run when booting up. And this will of course be source/electron/main. So our main file right here will run once Electron starts. And of course, we will need a dev script for that as well. So let's just rename the first dev script we got to dev::react and add another one, which is going to be dev electron. And it will just run electron dot. So start an Electron process in the current directory and take this main script right here. And now let's just try that out real quick. npm run dev electron. And as you can see, we got a blank window. Well, why is that? We can just head to the view up here on a Mac, or if you're using Windows, then this should be in a menu bar right under this bar up here. And we can just run view toggle developer tools to see the normal developer tools and get our error. And we can see it didn't find a file. So what did it try to request? Let's just reload real quick. And we can see it tried to get file, assets, index, blah. That isn't what we need because, of course, the assets directory isn't on the root of our computer, which is what it tried to get right now. It is actually in a relative position to our index.html. So if we just head into the index.html right here, we can see it tries to require /assets/index, which is exactly what we saw. But of course, on a Mac, slash means the root of the file system, which is not what we want. We actually want ./assets in both of these positions right here. So how do we actually solve this? Well, it's actually quite simple. We can just go into a vite config right here and say the base path of our project is ./ instead of slash. And now if we just npm run build again to basically recreate this index.html file and wait a moment for it to be created, then we can now run the Electron app again, wait a few seconds, and we should see that our UI is now fully loaded inside of our window. And of course, all the React state is also still working. And now what we've got is basically a local Electron app that can use our local UI with some local state, of course, as well, that is fully interactive using React. And yeah, it just creates this awesome little window. So next up, let's get into actually configuring this with TypeScript to prevent some errors in the future. And luckily, it's actually quite simple to convert all of this to TypeScript, especially because we've already got TypeScript installed, because as you can see, the vite project already contains a tsconfig. We are not going to use this TypeScript config though, because it expects front-end code, which we don't really have in our Electron app. It's just a node project. So the first thing we're going to do is tell the project, so the vite project basically, to exclude source/electron. Which means that we're going to define our own TypeScript config for the Electron code right here. So go to the Electron directory, create a new file, tsconfig.json. And this way we can basically now tell TypeScript what it should do to exactly those files inside the Electron directory. So let's just turn this file right here, the main.js, into a main.ts and define a little type in here. Type test equals string, just so we've got some TypeScript code here that would create an error if it was tried to run using JavaScript, because JavaScript doesn't know what a type is. And then we'll just add some config in here. So this config will simply just be all of this. So basically, what should the TypeScript compiler do to our code and what should it expect from our code? So what this will do is basically tell TypeScript, okay, here are all of my Electron TypeScript files. Please convert them to JavaScript using the following directives and put them into our out_dir. So let's go through all of this. First of all, we are enabling strict mode. This is something you should do with basically all of your new projects, because strict mode enables you to have null safety and all of that stuff, which is really helpful. And when you're creating a new project, you should basically always set strict mode to true. Then we're telling TypeScript to create ES module syntax. So basically import and export instead of require and module.export. This is because Electron expects us to use ES modules in the newest versions, especially because our vite project also says that it's a module. So we of course want TypeScript to generate an ES module, which is best done using ES next as a target. And then we'll also tell TypeScript that our code will be written in ES module syntax, by using module. So basically we're telling TypeScript, hey, we're going to create a node project using ES_next basically. And this will tell it, hey, convert my ES module code to ES module code. Don't convert anything basically, just remove all of the types. Then of course we need some place to put our generated JavaScript files, because TypeScript will basically just copy our TypeScript code, remove all the types and paste it somewhere else. And this will be 2 folders up from our tsconfig. So one folder would be source, 2 folders is basically on the same level as this dist react code. As you can see, I've already played around a bit, so we can actually see dist electron right here. And then we'll also have ignore errors from dependencies. So basically skip libcheck will say if any of our dependencies don't match these rules right here. So for example, they aren't using strict mode. Then we of course still want to be able to build our code. And for that to work, we will need to tell it, hey, don't check if the libraries support all your TypeScript recommendations. They are JavaScript anyway, so let's just ignore all of that and use them just the way they are. You wouldn't want your project to not build after all if you just have a dependency in there that doesn't support what TypeScript expected to. Now we will of course also need to somehow tell TypeScript that it should run this config. And for that, we'll just add another script to our package.json, which will be transpile electron. And transpile electron will just run the TypeScript compiler using the project we just defined, so source electron tsconfig, which will basically just compile all TypeScript files inside of the electron directory, which is a really simple way to handle things. So now let's just try that out. So I'll just remove my existing dist electron directory and run npm run transpile electron. And now after actually saving, we should see that when it runs, our new directory is created, which is up here, dist electron, and it contains our main.js. So now we of course also need to tell Electron that it should run the generated file and not the one in a source directory, which is really easy. We'll just change this main bit right here from source/electron to dist-electron/main. And now if we just npm run dev electron, we should see that everything is still working, even though we now actually have TypeScript code. And if we just head into our main.js, we can see it's basically the same code as before, just without the type we just defined. So now there's just one more thing we need to do so that we don't commit anything that we don't want. We need to exclude this electron from our git tracked files by heading into the git ignore and basically doing the same as we did with dist react, just adding dist electron into here, saving. And now our Electron project can just use TypeScript without us needing to worry about just about anything, which is really, really helpful. And now there's basically just one more step we need to do until our app is ready to be developed on, which is setting up Electron-Builder. So let's npmi save dev Electron-Builder. And after it's done, we can actually already create a config for it. So in many documentations, you will find that people add a build property into the package.json and put the config in here. This is fine, but it's not as easy to differentiate as if you had a separate config for Electron-Builder. So this is what we're going to do. We're going to create a new file called electron-builder.json, and that config will contain a few settings. It's going to be an app ID. The app ID is basically a normal standardized way of naming your app. So it starts with com, then your company or personal name. In my case, it's going to be n-Ziermann, and then your app name. So something like prepare for my course preparations, or something like Electron course, for example, like this. Then we're going to define what files should be included in our app. So of course, this should be our source code, so our JavaScript that gets compiled from our TypeScript, and our HTML, so a dist react folder. And then there are just 3 more settings, basically, which are the operating system specific settings. So what should my Mac build create? So a DMG, which is basically an installer for Mac apps. Linux, I want an app image, so a portable Linux application that runs on most Linux distros. And because Linux also allows you to categorize your app so that it can be displayed in a different manner, I also want to say that my app is a utility. And then on Windows, I actually want to create 2 apps, so a portable exe and an MSI installer. Hey, future Niklas right here. I just realized that there's a really minor issue with this configuration right here, because it works perfectly fine for Mac and Linux builds, but there's a really small issue with Windows builds, preventing Electron-Builder from actually creating a finished build. Because for some reason, Electron-Builder will require you to always set a desktop icon for Windows builds and just won't use the default Electron icon. So you can just go ahead and say icon is / whatever your icon is called. As you can see, I've created one right here, it should at least be 255 by 255 pixels and ideally a PNG. And as you can see, the build does actually set this desktop icon for my project right now, even though I'm of course on Mac, so the build worked before as well. But this should be enough for you to continue following the course, even though the rest of the course will of course not show this icon right here, but the finished project on GitHub will of course contain it, just so everything works on every operating system. Let's move on. And now there's just one more thing we actually need to do here, which is heading back into our package.json and adding the required scripts to it. So if we just head back to the scripts section, we can add these. And you can see most of this is actually really similar. So we first of all transpile our Electron app, then build our HTML, and then run Electron-Builder with Mac ARM64. So basically I want to create a Mac build for ARM processors, so an M1 for example. And then for Windows, basically all of this is the same. I just say I want a Windows build for x64, so a normal Intel or AMD processor, and the same thing for Linux as well. And now we could actually already try to run one of these. If you're on Windows, then you might need to run this as administrator because it will need to install some stuff on your system for the first time. And if that doesn't work properly, then just try to run it as administrator. So now let's just go npm run dist mac. And we should actually see that it can't currently create our project properly because there will be a little really tiny error, which is that even though Electron understands this main bit up here perfectly fine, Electron-Builder will actually expect you to add a file extension in here. So let's just call it dist-electron/main.js. Run this again. And if you're still having trouble, then please make sure that the system you're targeting is actually the same type of operating system that you're using right now. So if you want to create a Windows build, do try to create it on Windows and not on Mac or Linux. It will most likely work to create a Windows build on all types of operating systems, but sometimes there can be issues with exporting to different operating systems, so just try to use the same one you're exporting for when creating your builds. Alright, so now it's done. It might have taken some time, that's no issue whatsoever. It will download some stuff, it will compile some stuff, whatever. But now if we just check out, we should have this dist folder right here. For my case, I created a Mac build, so here I will see a Mac ARM64 folder, and also my DMGs right here. So there are different ways of running this now, depending on what you build. On Windows, you should just see an exe. On Linux, you should just see an app image. And on the Mac, you see a few files, but the most important one is still the DMG. And of course, depending on what you configured here, these things will differ. So for example, the portable will create an exe, the MSI will of course create an MSI. But to now test this out, let's actually head into a folder right here. I'll not install the DMG for now because on Mac, there's actually a full version of this thing in the Mac ARM64 folder that I don't need to separately install. I'll just open it. And now we should see that our Electron app is booting up just fine. So we've now actually created a fully working Electron app as a bundled project that can run on any separate machine without needing to install Node or whatever other software, which is really, really awesome in my opinion. And now if we just get some info about this app, we can see it's 240 megabytes big. And that's because, as I mentioned before, it bundles a whole Chrome browser. So this is one of the reasons why many people don't like Electron, because it creates large apps. Because of course, bundling Chrome will take up a lot of space. But for our case, this is totally fine. We just want to create an app with an awesome user experience using our existing knowledge. And this is something we've just done. We've just created a simple app using HTML, CSS, and JavaScript, or rather Electron, React, and TypeScript. So now let's get into actually developing the app. But first, let's try to do some DX improvements so our development will be a bit smoother without needing to run 50 scripts to get everything done, transpiling stuff and all that mess. We'll try to optimize out of this a bit now. So let's do it. And of course, our most important development experience improvement will be that we don't want to run as many scripts to get developing. And to do that, we'll actually use Vite hot module reloading when we're in dev mode, instead of just building the frontend and bundling it inside of Electron, because that's just requiring us to reload every time we change the frontend, which is not really effective. So to do that, we'll actually need one dependency. So npm i -- save dev cross-env. And this is basically just used so that we can set environment variables on both Mac, Linux, and Windows. Because on Mac and Linux, you can just go ahead inside of your dev Electron and say node_env equals development, and then run Electron dot, and the node env will be set. But on Windows, you will need this cross-env bit in the front. So cross-env, then your environment variable, which by default should be node-env because that's just standard. Then we'll call it development and run Electron. All right, so now we know if we are in development, right? But how does our code actually know that? Well, let's just create a new function in our Electron code right here called util.ts, and we'll export function isDev from here. And this will basically just return a boolean, and it will return process.env.node.env equals development. So basically, when we're in development, so when we are running using the dev script, then this will be true. Otherwise, it will be false. So this way we can basically feature toggle different tools when we're in development or when we're in production mode. So for example, we can use the Vite HMR, so hot module reloading server, when we're developing, but use a pre-built application when we're in production. And that's exactly what we're going to do now. And the first step to achieve that goal is to actually set a fixed port for the Vite server. So we're back in our Vite config right here, and we're going to configure our hot module reloading server. So the server is going to be on port 5123. You could choose any port you want, but I just thought that number was nice. And we'll tell it that if the port isn't available, then please warn us, because what we're going to do now will only work when exactly this port is being used. And now if we were to actually head back to our package.js and run npm run dev react, then we should see that it now opened up on port 5123. And if we just check this out, then we can see here it is. Everything worked just fine. Perfect. And now we obviously also need to get this running. So now let's just try to use our changes right here. So if isDev, then do the following. Else, use the stuff we did before. So if we're in dev mode, then we want main window.load URL. And this is basically the URL with the port we defined for Vite. So basically on a local machine, use the Vite port and give me whatever it outputs. And then if we're not in dev, then we of course want to build with our production files. So this-react/index.html. So now to try it out, let's first of all go ahead and transpile our Electron app to actually turn all of these new TypeScript changes back into JavaScript that can run in Electron. Then let's just spin up our Electron server, and we should see that it actually creates a blank screen. Why is that? Well, the Vite server is currently not running, so HTTP localhost 5123 doesn't return anything yet. So let's close this Electron app again, go into a second terminal, start the Vite server again. Now let's go into the main terminal and start Electron again. And now we can see that our app is actually running. And we can also try out the hot module reloading real quick by basically just putting these windows right next to each other and just inputting a 1 right into here. And we can see the hot module reloading works. So we now don't need to rebuild our front end and restart the Electron app when working on front end code. We only need to restart when we change the Electron code, which is already quite a nice DX improvement. But now let's actually get into not needing all of these commands, because now we also need 2 terminals. That's starting to get ridiculous right now. So let's optimize all of this a bit. And trust me, this is the last thing we'll do until we finally get to development. I just think this is such a good DX improvement that I can't not tell you about it. So let's install one last package, npm I save dev npm run all, which basically allows you to run multiple npm commands in parallel while still being able to abort all of them simultaneously using Control-C, which is really helpful, trust me. And now let's just do some improvements right here. So first of all, we can say whenever I want to start the dev Electron app, I'll first of all compile it. So basically, when I run dev Electron, I want to say npm run transpile Electron. And when that's done, then I will start the development server using cross-env node development and Electron dot. So this way we already spared one command. Now let's also create a little dev script right here. And this dev script is extremely simple. It will just run npm run all -- parallel. So run all of these commands that are coming up in parallel. And then we just run dev react and dev Electron. Make sure that none of our commands are still running in any of these terminals. And now if we just hit npm run dev, we should see that both of these things spin up simultaneously. And now our Electron app is spun up right here. And we can try out the hot module reloading once more by just heading back into our app right here, opening up the app.tsx and just removing our little testing one. that we inputted. And we can see it's working absolutely fine. And I can abort both of these simultaneously, so I won't spin up like 1,000 Vite servers or whatever, which would be annoying. And especially with the strict port stuff, you can get in really confusing situations with that. So now we can basically just run one command, which is npm run dev. It will spin up our front end, it will compile our TypeScript, and then it will start up an Electron app, all using just one command. So now we are finally ready to get developing. And first of all, we of course going to need to pull all of the system resources, so CPU usage, RAM usage, and storage usage from our machine. To do that, let's first of all remove this testing type we created and create a new file to have all of this separated out a bit called resource-manager.ts. And then here we're going to export function poll resources. And this function will basically just be our polling that we're going to start to basically in an interval inform the UI that there were changes to the resources so that it can update. And of course, we're going to need an interval to poll it. So we'll just define a constant up here really quick. Polling interval. And we'll say that we want to update this twice every second. So every 500 milliseconds. And now we can just go ahead and say set interval. And whatever we put into this function right here will of course then run twice a second. Perfect. So now we actually need to get our data. And for that, we're going to need a few functions and another library, which is OS-utils. So let's just go ahead and install it real quick. This time not as a dev dependency because we actually need it in the finished build. So npm I os-utils, which we're going to use to get our CPU and our RAM information. So let's start off with our CPU utilization right now by defining a function get CPU usage. And what it will do is basically just call OS-utils, which we're going to need to import. Import OS-utils from OS-utils. It can't find a declaration for this module, so let's just get that as well as a dev dependency. npm I-safe dev add types/OS-utils. This is necessary because OS-utils doesn't bring their own types. So if we want TypeScript and full type completion and stuff, then we of course need to get the types separately, which are available in add types/OS-utils. This we can save as a dev dependency because it only contains types that won't be put into the finished bundle anyway. All right, so now we should get some good autocomplete as well. And we can see there's already a lot of stuff and CPU usage seems really good. And now this takes in a callback with the percentage. So let's just try that real quick and we'll just console.log this percentage. And then we'll just say that on every interval, we want to get CPU usage. Now let's just try this real quick by running npm run dev to spin up everything. And then we should see that this is logged inside of our console now. So let's just wait a bit. And now we see that we don't see anything. So why is that? Well, we haven't used the poll resource method anywhere. So let's just go into our app real quick. So the main.ts and just start polling the resource as soon as possible. Quick fixing this by importing it. And now as soon as our app is ready and our window is rendered, we will start polling our data. So let's just start this once more. Wait a few seconds until everything is ready. And then we should now see that my CPU usage is being logged out. Perfect. But now I of course don't want this inside of a callback. I want to return this from this function. So what we can do to do that is actually wrap a promise around this to basically turn this into an async function. So to do that, we'll just return a new promise. And this promise basically takes in a callback that takes in the resolve function. And basically when you call the resolve function, then the promise will be returned and you can basically await the function or value that was passed inside of this resolve. So what we can do now is basically just say, okay, when OS-utils.CPU usage calls its callback, we will just pass the value that is passed to the callback back inside of our promise. So now when OS-utils.CPU usage calls this resolve function with a percentage, we will basically get a promise with that percentage that we can await. So let's just try that by actually going ahead and saying, I want to await get CPU usage. I'll of course make this an async function to be able to use await. And now we can just say const CPU usage equals await get CPU usage. Let's just console log that real quick again. CPU usage. Restart everything. And now we should see that everything still works the same. But now we've got a easier to use and more modern function to work with, which works perfectly fine, as you can see. And now let's do the same for our RAM. And it's even simpler, honestly, because it's actually a synchronous function. So we can get our RAM usage by calling osutils.freeMem% and subtracting the value from 1. Because this is a value between 1 and 0, and subtracting 1 from the free % usage would of course give us the used usage. So basically 1 minus 3 is used. And now we can just do that as well and just say const RAM usage equals get RAM usage like this. And then we'll just const.log an object real quick. So CPU usage and RAM usage, try this once more. And now we should also see our RAM utilization appear in here. Let's just wait a bit. And yeah, here it is. Perfect. And now let's get into actually getting the data about our disk as well. For that, we're going to use the built-in node module FS, which will only work for this, starting with node version 18. So if your version is older than that, then I'd first of all recommend you update because those versions aren't supported anymore. And also, if you don't want to update, then just use any other library that can do that. There are many others out there on NPM. But we are just going to use FS to make our life a bit simpler. So import FS from FS, first of all, like this. And then we're gonna define a little function that I'll actually copy because it's easier to explain than to actually live code it. So here we got our get storage data. Our storage data will use fs.statsfssync, which is basically a function that gives us the synchronous stats, so basically without needing a wait or whatever, about a specific region in our file system. So we'll basically get the root file system because we want the whole disk space on our complete machine. And then we can just say, okay, if I'm on Windows, I of course want my C drive to be tested. So basically where Windows is installed, right? And if I'm not on Windows, so on Linux or Mac, I just want the root of my file system because on Mac, everything starts at /. Same on Linux. And then we can basically use the data we got from here called stats to calculate everything else. So our total storage space is basically the size of a single block. So on a disk, everything is stored as blocks of a specific size in bytes. And then I, of course, want to know how many blocks there are. And if I now multiply the size in bytes of each block times the amount of blocks, then I will know how many bytes in total my disk has. And the same thing for the free space on my disk. I need once again to know how big each block is. And then I can just get how many free blocks there are. If I now multiply the amount of free blocks with the space that each block takes up, I know how much space is free on my drive. So now to get my total space on the disk, which we're going to use later on, I can just say I want to divide my total space by 1 billion, which is basically to get my storage space down to gigabytes. So dividing bytes by 1,000 would be kilobytes, by 1,000,000 would be megabytes, then we get gigabytes right here. And then we just floor this because I want a singular value without any decimals. So for example, something like 240 gigabytes instead of 240.267 or whatever. And then to get our usage, I'll first of all go ahead and say free over total. So how much of a percentage is currently free on my disk? And then once again, just like with the RAM, I of course subtract that value from 1 to not get the free space, but the space that's used up currently. And now we can just get our storage data up here as well. So const storage data equals get storage data. And here we can now just go ahead and say storage usage is equal to storage data dot usage. So let's just try that out as well. And now we should see that all of these three values are logged out. And we should be able to continue working with them from now on. And you can see all of this is logged out. And of course, the storage usage is a permanent value right now, because why would it change? I'm not really installing anything right now, so no reason for this value to change right now. Perfect, so now we're getting all of this dynamic data about our system, but we might also want some static data like our CPU name, how much memory there's in total, how much storage there is in total. All of this data won't change. So we can just get it once and basically just display it in our UI to make it look nicer. And to do that, we're just gonna export another function called export function get static data. And what get static data will do is first of all use one function we already have, which is the storage data. So const total storage is equal to get storage data dot total. So now we got the total storage in gigabytes. Then we also want our CPU model. So const CPU model is equal to OS, which we're going to need to import. This is another Node standard module, so we actually don't need to install it. Just go import OS from OS. And then we can actually go ahead and say os.cpus. We're just going to expect that there's only one CPU in the system. So we'll get the first one and get the model from that. So this would basically be something like Apple M1 or i5 7500 or whatever. Basically just the name of your CPU, which is really nice to display in something like this resource manager we're building. And then lastly, we also want the total memory in gigabytes, which we can get through using osutils.totalmem, dividing this by 1024, because this is actually stored in mebibytes and we want gigabytes. So basically to get the 8 gigabytes, which are actually gigabytes, we just divide by 1024 to convert these mebibytes into gigabytes. And then we floor this result once again, just so we don't get any awful looking numbers. We just get a singular number like 8, 16, 32, whatever. And now we can just go ahead and return all of these three values real quick. So return total storage, CPU model, and total memory in gigabytes. And now we also get some static data. So next up, let's actually try to get all of this data inside of our UI to actually display it and build a nice looking interface around it. But of course, to actually allow our backend to send data to the frontend, we need to somehow understand how the backend and the frontend communicate using this IPC event bus right here that I've talked about earlier. And to understand that, we've got this little illustration right here. And this illustration basically shows us how the app and the UI communicate using the IPC bus in the middle. And what this IPC bus basically enables us to do is to have our app basically, first of all, send data to the frontend, or to also have our frontend send data to the app and even wait for a response from the app. So basically, we've got a bidirectional way of communicating between the two apps using a custom protocol. And this custom protocol will be called the IPC renderer object in our frontend. But the issue is that this IPC renderer object is non-standard, so it's not part of the default APIs in a Chrome browser. So the app will need some kind of a way to basically send this object over to the UI so that the UI will be able to use the IPC event bus. And there are actually multiple ways of doing this. The most common one you'll see, unfortunately, is actually setting up some unsecure settings and then using window.require Electron in a UI. This seems absolutely fine because the IPC renderer is part of the Electron object, so it can only be imported inside of an Electron app, and this would enable us to use it inside of the UI, which does seem good, but using window.require will allow us to require every node module there is. So also something like FS. So somebody who would be able to interact with the UI using something like XSS, for example, would also be able to interact with the whole file system and basically every node module that is installed, which we of course don't want. But luckily, there's a more ideal solution, which is called a preload script. So basically, we can register a script that has similar permissions to our app and runs before our window is initialized to then basically append data to the window object inside of our browser window. So you can see here we can import Electron, we can get the IPC renderer object from Electron, and then we can actually define a little object right here that will then be appended to the window object inside of our UI. So there we will have something like window.electron and then access to this little object. So window.electron.request static data could be a wrapper around the IPC renderer function that will then interact with the IPC event bus to basically not give full access to all the Electron APIs, or even worse, all the system APIs inside of our UI, but only really limited access to those functions that we actually want the user to be able to use. So basically our preload script will have some kind of a wrapper around the IPC bus using IPC renderer that will be used to request static data from our backend. And this singular function that will wrap this functionality can be exported to our window so that the UI is actually able to use this specific method and get some static data. And of course, I know that all of this sounds really complicated right now. We've got all of these different scripts and it would be awesome if we could just require stuff, but of course for security reasons that doesn't work. So we set up a preload script in between our app and our UI to basically allow us to add a little bridge of content that we want our UI to be able to access using this little object right here. And then this bridge is everything that our frontend can use to actually interact with this IPC bus to receive and send data to the backend. And really, don't worry if you don't understand this yet. We'll implement it shortly, and as soon as we've implemented it, you can either look back on this little explanation to better understand it, or even better, you might already understand what it is after having implemented it yourself. So now let's get into actually implementing it to make this as easy to understand as possible. Alright, so now before we actually implement the IPC part, let's start off by actually loading a preload script and getting to know how all of this works, because that's the initial part we need for our IPC process to actually be available inside of our browser window. And to do this, we'll actually need to now change the settings we are adding when creating our new browser window. So in here, we can do a lot of stuff like setting a width, for example, so the initial width of the window or the title, all of this stuff can be configured in here, but what we want is the web preferences. So basically everything that is connected to how our web browser will have permissions and all that stuff. So in here, you could do something like turning off context isolation or enabling node integrations. Both of the things I just told you not to do, because those can cause security vulnerabilities, because they will basically allow you to access everything in Node.js from your browser window, which is not something you want to do in many cases. What we actually want to do is adding a preload script. Now the unfortunate part right here is this is actually a path, so you can't just add a function in here or whatever. This expects a string, which is a path to a file. And because this path will be different in develop and production mode, we'll actually add a new file for ourselves right here, which is the path resolver.ts. And our path resolver will have a really simple script, which is get preload path. And our get preload path will of course need to import a few things. So let's do that real quick. Import path from path, because we of course want a normalized path that works on Mac and Windows. Then we'll also need the Electron app. So import app from Electron. And lastly, we'll need our isDef method that we defined previously. Let's import that. And now let's get into what the function actually does. So we are joining a path in a cross-platform way. So basically we get the path of our app, which Electron luckily gives us a little helper for, called getAppPath. And then when we are in development mode, we are adding one dot. So basically in the directory we are currently, go to dist Electron. And when we are in production, we actually need to go up 2 directories. And then we of course want dist Electron dash preload.cjs. So why is it called CJS? Well, Electron-Builder will actually bundle all of our Typescript files inside of this Electron folder into a singular file in the end. And because we actually need to load this using the file system, this can't happen. So we'll just add another extension and write this in CommonJS to basically avoid this. And this little workaround right here is also the reason why we're going up one directory when we're in the production build. We will later on tell Electron-Builder to actually handle this file separately, thus causing it to be placed in a different directory. So now let's just create a new file called preload.cts, because we of course want TypeScript, and compile it down to CJS later using the TypeScript compiler. And here we can now do whatever we want basically. So we can just go const electron equals require electron. Remember, we are writing CommonJS right now, so this needs a require keyword. And now we can basically do whatever we want. So electron dot, and now we have a lot of stuff right here, like a context bridge, for example. And this context bridge can now be used to basically bridge data between our Electron process and our main window. And the way we're going to do that is by calling the expose in main world function. And what expose in main world does is basically just append whatever we're adding here to the window object. So what we want to do is say we want to add an object called Electron, so this name right here, to our window. And then this thing should have the following content. And here we can now just add just about anything we want. I'll just go ahead and add these 2 methods right here, because those are quite close to what we actually want later on. So we want one method to subscribe to our statistics. So basically our backend will constantly send us data every 0.5 seconds, and we want to subscribe to that using a callback. And whenever the callback is called, our statistics will basically be sent to the front end using that callback. Right now, we are just calling this callback with an empty object because we didn't implement any IPC stuff yet, but we can do that later on. And then we add another method called getStaticData, where our front end will later basically go ahead and tell our backend, hey, I now want the static data. So basically, what's my CPU name? How much storage do I have? How much RAM do I have? please send it to me. And here we'll also just go ahead and say we'll console.log the word static. And now this should theoretically, when we save everything and actually use it everywhere, so get preload path should of course be used here as well. If we now use all of this and actually run it, then we should be able to already test it out inside of our dev script. So npm run dev, wait a second. And now here's our app. We can just head over here to view and toggle our developer tools. And now we should see window.electron. And you can already see that these two methods are here. So let's just get the static data and we can see we console logged static. And now if we just subscribe statistics and for example add a callback that console.logs1, then we can see this callback was called and our 1 was logged. So essentially what we're doing here is we are telling our main window, please run this script before you open the window, so preload it and attach everything we want in the context bridge to our window under a keyword called Electron and just allow us to use these specific things. Now you could of course still do some stupid stuff in here, like saying, okay, I want everything in Electron to be compatible, so I just import all of Electron here. That would in itself of course be another security vulnerability depending on your app. So it's best not to do that. This is why we're adding these functions that basically wrap some logic so we don't give too much power to the UI basically. So what we're doing is basically just saying these two methods can be used by the UI. They do this. So please expose it to the window and then the UI can just use it in whatever way it pleases. So we just check this out real quick using our UI right here, head it to the window and just set something like window.electron. What was it called? Get static data. Then you will first of all see that there are type issues here, which we're just going to ignore for now. So add ts ignore. We'll get into that later because all of this process isn't type safe in itself anyway. So we aren't adding the types right now. We're adding them later on, but don't worry, it won't take long. Now let's just reload this and we should see that our UI now automatically logs this value because it can just access it on the window. And here we can see static was logged 2 times because we're running in React strict mode, which of course runs everything twice. But unfortunately, if we now actually go ahead and build this using npm run dist with whatever operating system you choose, then we're going to see that this won't work in exactly the way we want. So let's just try it out real quick by building it and waiting for a second. Then we can now see that there's an error because nothing is rendering. So let's just take a look at our developer tools real quick. And we can see, okay, cannot read property of undefined reading get static data. And that is because our preload script didn't actually run, which you can see here, unable to load preload script. And that is the case because we didn't actually tell Electron-Builder to include this file. Remember, we intentionally called it .cts so that this isn't bundled in the normal one file fits all solution basically, because we need to import it as a separate file right here in our get preload path method basically. And now we need to tell Electron-Builder to actually put that file into that position so that it can be imported at runtime. And how do we do that? Well, let's just head into electron-builder.json right here. And here there is actually another flag or another category you can set called extra resources, where we'll define every file that needs to be imported separately from our code. So basically as a unique file. This could be something like an image you want to include or also something like a preload script, for example. So let's just add the path to our preload script right here, which will of course be distelectron/preload.cjs. Remember, distelectron is the directory where all our compiled TypeScript/JavaScript code will end up. So basically all of these TypeScript files are converted to JavaScript inside of distelectron. And of course our preload.cts will be converted to a preload.cjs right here, which can then be used by Electron-Builder to actually give us the desired result. So now if we just compile all of this down into an executable once again and wait for a few seconds, then we can now see that everything is spinning up perfectly fine again. And if we head back to our developer tools real quick, then we can see static was logged and window.electron contains our 2 functions right here, which is exactly what we want. So we now actually got some communication between our main Electron process and our main window, using both the dev and the production build. And now the only thing that's left to understand is of course to really go into why these dots are different right here in our production build. And if we just take a look at our build using the terminal this time, we'll just cd into the dist directory. And because I've created a Mac build, we can actually dig really deep into the files. So let's also do that by just doing ls. And here is a Mac ARM64 directory that we're going to go into. And this now contains our app. So this is the actual executable you can just click on in your terminal. So we just do open dot. You're going to see this thing is our Electron course that we can click on to open the app. But because we're using the Mac build right now, we can actually go deeper by actually cding into this little file right here. So cd Electron course to that. And as you can see, there's content in here. And now we can just cd into the contents. And this then will contain more stuff. For example, a macOS folder that will once again have the application in it, and the resources folder, which will actually contain all of our code and stuff. So let's just go into resources right now. And we'll just open this using the actual file explorer to have a better way of understanding what's going on here. As you can see, there are multiple files right here. There's a desktop icon, there's an app.asar file, and there's also a dist electron folder somewhere in here. And this dist electron folder now contains our preload.cjs file. And this is basically what we're doing when we're defining extra resources. These resources will land directly inside of the resources folder under the same folder structure they are in our project. So basically, when you're looking at the root directory, we've now copied the dist electron folder, but the only content we're copying is basically the preload.cjs. So basically everything you put inside this extra resources bit will be put inside of the resource directory of your app. Okay, so all of our extra resources land inside of this resources folder where we're basically already located when running locally, because it basically mirrors our current file system in our app. But where is our code actually running? Why do we need to go up one directory? Well, this is where it becomes kind of tricky, and where also the reason comes in why we use a CJS file. All of our bundle code will actually be located in this app.asar. And this is not a real directory, it's basically a fake directory, because this is kind of a bundle basically that will contain all of our code. So we can't actually use file system reads for our preload script, for example, to read stuff from inside of here. But everything will basically be bundled in kind of a custom format. And we can escape from this format by basically just going up one directory. So this isn't really a directory, but for all code's sake, we can treat it as one. So our code is basically located inside of here. And if we want to access anything outside of this directory, we just need to go up one directory, which is what is happening in our path resolver. So basically when we're in dev mode, we're accessing this electron folder right here from our root of our app. And if we are in production, we'll basically leave the app.asr using these two dots, and then accessing dist electron preload.cjs inside of the resources directory right here. So now that all of this is clear, let's get into finally sending some data over the IPC event bus, which was the whole reason to set up this preload script so that we can finally display something inside of our UI. Let's go. So to finally now let Electron send our pulled data to our frontend, we first of all, of course, need to tell it which window should actually receive the data. So this will, of course, be our main window, which is of type browser window. And of course, this main window will need to be passed as a reference to poll resource because we are currently not in a scope where it exists. And now, instead of console logging our data, we can say main window.webcontents. So everything that Electron needs to interact with the actual window is inside the web contents. And here we can now say send. So send an event given a name. The name of our event will be statistics. And the payload of our event will, of course, just be this big piece of data that we're currently logging. So let's just copy it over. And now we are basically saying on an event bus called statistics, we are sending this data every 0.5 seconds. And if the front end wants, it can listen to it. If it doesn't want to, then that's absolutely fine. We aren't expecting anyone to listen in case that nobody's there to listen because the window, for example, hasn't opened yet. So now we can just save this, head over to our main file because of course we need to pass the main window to our poll resource method now. And after saving, everything is fine so far. We can now just head to our preload script and actually use the callback we defined before in a proper manner. So now in here, we can now say electron.ipc renderer. So basically the UI part of the IPC protocol. And here we of course want to add a listener. So on receiving the statistics event, which we'll just copy from over here real quick. On receiving the statistics event, we want to call the following function. And to now get our data, there are actually two parameters. The first one is the event. You can basically use this event to get information about who published this event. In our case, this will always be the main process. So we aren't really interested in the event right now, but later on, we will actually do some checks to make sure that events aren't coming from untrusted sources, but not right now. That's something for another time. So we can just say the event isn't really as important right now, so we just call it underscore. And then we just add our data, and our data are actually the statistics we're currently sending. So what we can do now is actually just go ahead, say callback, and call our callback with the statistics. So stats right here. And now this should already be working. So let's just head to our UI, remove this window.getStaticData bit right here, and actually add a use effect in here to do the actual subscribing. We're doing this in a use effect, of course, because given an empty dependency array, the use effect will run only on the first render and not on every render. And we, of course, don't want to subscribe a million times. We only want to subscribe once. So now in here, we, of course, need again to add ts-ignore all of this, because, again, we didn't define the types. That will be the next step coming up. And here we can now just say window.electron. Then we'll just copy subscribe statistics from over here. And then we can just say this is our stats, and we'll just console.log them. Again, this isn't much different from what we did before, but now we aren't logging them in the Electron backend, we are actually logging them in the frontend. So let's just try that out real quick by running npm run dev, waiting a few seconds, and then we should see that our UI is now popping up. And if we head into the developer tools, we can see our usages are already picked up and everything is working just fine. So our communication from the backend to the frontend in basically a UDP style manner, so we're sending data and not really caring about if it's received, is now working. So now let's get into the other direction of saying, okay, I'm the frontend, I want to get the static data, please respond to me. So I expect you to answer. So let's take a look at how to do that by actually heading into our preload script once again, and now saying electron.ipc-renderer.invoke. Now, if we just leave this right here, we can see that invoke resolves with the response from the main process. So basically, while send just sends data and doesn't really expect a response, invoke is there to expect a response. So here we can now just say, I want to define an event called getStaticData. We actually don't need a second parameter because invoke will actually just return the value that the IPC main process returned as a promise. So just defining what event we actually want to listen for is completely plenty. So now to actually listen to this event, we'll of course need to go back to our main process, say IPC main, and then we could do something like on, for example, but remember on and send are for more of a UDP type of communication. So sending data and not really expecting anyone to listen for it. What we actually need to do is to handle an event because the UI expects the backend to respond. So it needs to handle it. And now we of course need to handle the same event that's coming in. So get static data. And when this event comes in, we will call another callback. Again, here you can get the event and we will verify this exact event later on, but not quite yet, because without any types, all of this is really not as helpful as it might be at a later point in time. Remember, the types come next, so don't worry. And now we can basically just go ahead and say, I want to return get static data, which we already defined before. Remember, it just returns our total storage, CPU model, and total memory in gigabytes. And now if we just try this out as well by restarting our UI real quick, and just calling this in the console, because given that all of this is async, it would be too much effort to just mock it real quick. We can just run it inside of this console and everything is fine. And now if we just run await window.electron.getStaticData, we can see that after scrolling up a bit, because all of this loads really quickly, we get my total storage of 245 gigabytes, a CPU model of an Apple M1, and my total memory of 8 gigabytes. So we can now request data in more of a synchronous fashion. Sure, it's still async, but we are expecting a response. Or we can just send data to the frontend. Don't really care if anyone actually gets it, which is especially important because we might send data at a point in time where the frontend hasn't loaded yet, for example. So expecting a response would of course be detrimental in that use case. So these are the two types of communication that we are needing for our app right now. So let's now actually make them type safe, because all of the any's and ts-ignores are of course not really best practice, as you can imagine. So let's optimize this now. And to start off with our refactoring, we'll first of all handle the window object, so basically the type safety between our preload script and our UI, and then we'll go over to the IPC process. So to start off, we'll first of all need to define a new file to save our global types in. We're going to call it types.d.ts. And this file will basically contain all types that we share between our frontend and our backend, because importing the same file from the frontend and the backend can get really messy real quick, so we'll just define everything in here. Do be careful to not define too much in here though, as global types do tend to be kind of an anti-pattern in many cases, so just be careful here. And to get started, we first of all define a type called statistics, and that type will of course have all the fields from our statistics object. So to do that, we'll now just head over to our resource manager again and just check out what object we are putting in here. And as you can see, the object is just this right here. And for now, we can say we got a CPU usage, that's a number. We've got RAM usage, that's also a number. And of course, we need to close the object so that all our errors disappear. And we've got the storage usage, which is also a number. Now let's do the same with our static data. Just heading back to the resource manager once again, copying over this object and defining what it contains. So our total storage is once again a number. Our CPU model is actually a string because it's the name of the CPU. And then our total memory in gigabytes is of course also a number. And now we can just save this. And now we need to somehow add it to the window. So to do that, we'll just go ahead and say interface window. And an awesome part about TypeScript right here is if we define an interface that already exists like the window again, then we basically add stuff to the existing interface. So everything that's already part of the window will stay part of the window, but everything we define in here will be added to it. So now we can just define Electron in here, because as you might remember, in our preload script, we called our bridge Electron. So our object will of course also need to be called Electron. And then we can just add these two methods we're defining here. So our window will have a subscribe statistics method, which will return void for now. We will later on also add an unsubscribe method as a return type, but for now we'll just stick with that. And of course we'll need the type from before again. So this thing takes in a callback that will be called whenever the subscription gets updated. And our callback will of course get the current statistics. So the statistics have the type statistics right here. And it just returns the type void again. And then once again, we also copy over the get static data method right here. And get static data will of course also be a function, but this function actually expects a return value, which of course is the static data. But because we need to await the static data, as you might remember, we of course need a promise of static data right here. And now we basically already defined our window. So if we now just head into our app and try to remove this tsignore, we can see Electron is still not defined. Well, why is that? We didn't actually tell TypeScript to use this types.d.ts file yet. So let's head into our tsconfig at the root level, so the one for UI. And inside of the compiler options, we'll add a new field called types. And types is basically just an array of files we want to include that contain global types. And in this case, this will of course be ./types.d.ts. Remember, a d.ts file is for defining global types. So something like defining what a module looks like, for example, that didn't have type definitions, or for our use case, just defining global types. And now if we head back to our app, we can see Electron is now defined and subscribe statistics is also defined. And now even our stats have the type statistics, which is really, really awesome. And of course, the same thing now goes for our other method, the get static data method. But of course, this is only one side of the equation. We also want the other side to be type safe as well. So let's head to the tsconfig of our Electron project. So remember, source electron tsconfig.json. And in here, inside of our compiler options, we'll do just the same. So add global types. And of course, this will be types. And our types will be .. because we are two directories underneath our root directory. And it will again be types.d.ts. Okay, so just so you know, I did a little mistake right here. This is actually something that VS Code understands perfectly fine, but the TypeScript compiler sometimes has issues with. Don't call this .. types.d.ts. Just call it .. types, and the .d.ts will basically be inferred from TypeScript. So I've already implemented some functions right here, which you're going to see shortly later on. But just so we know that it's actually working, I'll just go ahead into the types.d.ts right here. Please ignore all the other stuff right now. And then I'll just say that the CPU usage is of type never, so that we just see that it is still breaking stuff if the CPU usage isn't right. And we can see type number is not assignable to type never, so defining it like this will still work, but it will also work while transpiling. Because without this change, npm run transpile electron would actually not work, which is something I didn't realize because I seemingly didn't do a build. So if we just rename this to d.ts again, then we're going to see that npm run transpile electron will run an exception, but calling it types will not cause an exception. And of course, please don't forget to do the same thing inside of our UI right here, where we also got ./types.d.ts, which of course just needs to be ./types. And now if we just save this and head to our preload script, we can now say that this object that we are appending to our window will of course need to satisfy window, and from the window we want the electron object. And now everything is working just fine, and we can even remove this any bit right here, or even the complete type right here. And our callback will still be statistics, because this is implied from the satisfies keyword down here. If you don't know what satisfies does, by the way, it basically just tells TypeScript that we expect this object to just be of this type. But instead of using as, where you basically just override the type, you tell TypeScript this object needs to have this type. And if it doesn't, then please throw an error. You could also define a variable that has the type window electron and then assign the value to that. But because we aren't really using any variables right here, we're just passing this as a parameter. Satisfies is the right way to do things. And now we've basically already achieved a type-safe communication between our preload script and our UI, even though this invoke method, for example, isn't type-safe yet. So if I just went over to the invoke method real quick. So in our main process, we've got this get static data right here. We could, for now, still just return an empty object and nothing would complain, even though the code is, of course, false now. So that will be a next step. But what we did at least achieve is making all of this between the preload script and the UI type-safe. Because if I now went ahead and just commented this out and returned something like null, for example, then it will complain because null is not assignable to a promise of static data. So we did improve our type safety quite a bit already. So now let's actually make the IPC communication type safe as well, using more global types, of course, so that everything is just working as optimally as possible, and so that we can just prevent as many stupid mistakes like confusing strings for numbers and whatever as possible. But before now finally getting our IPC communication to be type safe, let's take a look at what it currently looks like and what we're going to do about the issue that it has. So right now we've got our Electron side right here, and we've got our preload UI, so basically our preload script or our UI on the other side. And in the middle we've got IPC, which currently always uses any for any payloads we're sending over it, independently of what event we're actually using. So what can we do about it? Well, because IPC doesn't really allow us to, well, actually define any types, at least not easily, we'll actually use adapters. So basically what we're going to do is we're going to create adapters for sending data from one side to the other and for receiving data on the other side. And of course also vice versa, sending data from the UI to Electron will of course always have adapters as well. And then what we're basically going to do is we're going to say we only use IPC inside these adapters. These adapters will have full type safety from one side to the other. And this way what we're doing is basically encapsulating the IPC process in a type-safe shell so that no any types are actually escaping anywhere inside of our app. We are always having full type safety from one side of the adapter to the other and basically just ignoring the any types in between. And the way we're going to do that is by basically defining a mapping of types. So event 1 will have type 1, event 2 will have type 2. And then we're basically just defining a function. For example, we're going to call it send. And it will basically just wrap IPC renderer.send for an event name and a payload. But because we are using generic types in this send function, we can then just basically go ahead and say, for a given event name, I will always have this payload because the event name is a key of this mapping right here. And of course, if you don't fully understand this yet, then don't worry. We're going to implement it really quickly right now. And yeah, it will probably make a lot more sense then. And if not, then yeah, you're free to just rewind a bit, watch this again. And after having implemented it, it will hopefully make a lot more sense. So let's get into actually implementing this stuff. And to now start off our implementation, we're first of all going to head into a types.d.ts file, so a global type definition, and define our event mapping that I've just talked about. So I'm going to call this event payload mapping. And what we're going to have here is basically the key is going to be our event names, so statistics and get static data, and the values are going to be the types that are sent as a payload. So of course for statistics, that's going to be our previously defined statistics type, and the same for the static data. And what you can now imagine what we're going to do with this mapping is essentially automatically generate functions like this. So we've got a function right here that says handle get static data. So it's going to be our handler for our get static data function that we already have. Remember, it's basically the IPC main.handle for our get static data event, which will then just get the static data from our resource loader. And basically what we're going to say here is whenever we want to interact with our get static data method, we're essentially expecting a callback that's basically looking like this. So we don't get any parameters and we return static data. But of course, we don't want to define a function like this every time, even though this wrapper is already type safer than just using IPC main, because it at least checks that everything is right. If I were to return null right here, then we would get an error because null is not of type static data. But of course, we want a generalized solution that works every time and actually acknowledges our type mapping. So now let's just get rid of this. And of course also undo these changes right here by just undoing this. And now we're basically back to our normal situation with our type mapping intact, and we can actually get into implementing our generalized solution. Let's head into a util file and actually define a function. So IPC handle will basically be a wrapper around IPC main.handle. And IPC main.handle takes an event name, which we're just going to call key, and it will take in a callback. And right now this callback returns something. We don't know what it is yet. So basically we aren't really interested in anything about it right now. So let's actually pass through these little things. So the key will of course be a string, because our event name will of course always be some kind of string, and we'll use the mapping shortly after we've basically implemented a basic wrapper. And then we of course want the handler. So let's just call it handler real quick. And our handler will basically need to return the event type mapping, right? So we aren't using this yet, so let's just call it any. Now we of course also need to call the handler, so we can basically just say, I want to return the return value of my handler. So now how do I actually make this type safe? Well, first of all, we need to make this generic, because whenever you don't know what type something will have until you've got a parameter. So basically we will only know the return type of this function once we know what key we have. We will basically always need generics for something like that. So let's create a generic called key. Right now, key is basically an any type. So it complains because key is not assignable to type string. It could be anything. It could be a number. It could be whatever. To solve this now, we can say key extends string. And now we've basically done exactly the same thing as before, because the key is now just any type of string. But of course, what we actually want to do is we want to say that the key can only be one of the strings in the keys of our event payload mapping. So either statistics or get static data, because those are the events we've defined, and we don't want the user to actually use any events that he didn't define before. Or basically, we don't want any of us developers to do that, because the user doesn't define events anyway. So now how we can actually solve this is, instead of saying string, we can say I want the key of my event payload mapping. And what key of event payload mapping essentially does is, if we just define this right here, type test equals key of event type payload mapping, then this is essentially limiting my options of what types something can have to the left side of this object right here. So statistics or get static data. And this is basically now what I've limited my key to. So if I now wanted to call IPC handle with something like get static data or statistics, then that would work. If I passed X and a callback, then that won't work because X is not a key of event payload mapping. So now we've already limited it quite a bit, but this is still any. So what we can now do is basically say the return type of our handler will be event payload mapping, and from that we want the key. So basically, if I pass a key from the event payload mapping, so for example, if I pass statistics, then please get me the return value of event payload mapping statistics, which is of course the statistics object. And now if we try this again, so IPC handle, get static data, for example. And now it expects me to pass in static data right here. And of course, an empty object is not a full static data object, so it now complains. So basically what we've done now is made IPC handle completely type safe, because it is forced to always use this mapping right here. As long as we always use this wrapper and not IPC main.handle directly, we can assure that the handler will always do the correct thing in the background. And of course, if we now do the same thing for the invoke function in the front end, which we're going to do shortly, then both sides are type safe and we can basically ignore the fact that IPC main.handle itself isn't. Because as long as we always use our wrappers, everything will be completely type safe, which is exactly what we want. So now let's just go into exporting this real quick, head into our main.ts from Electron. And here we've got IPC main.handle right now. And here we can essentially just go ahead and say IPC handle, quick fix, import. And now this thing is completely type safe because it returns the return value of get static data. And if we just take a look, get static data, of course, returns static data. So the type safety is now complete. And if we just do a little sanity check right here by returning null, for example, then we can see that null is not assignable to static data. So this part of our project is actually type safe now. So now let's do it for all these other parts as well. And of course, given that we already are on the Electron side and not the front end side yet, let's also do the other function we're going to need for our backend basically, which is going to be sending data to the front end using the send function. So webcontents.send. Because remember, when we want to send something to the browser, we basically use the web contents of the browser window object to send the data. And yeah, I've just copied this function right now. As you can see, the key is the same. So key is just the generic parameter. Then we need to reference the web contents that we want to send something to. So basically, which browser window do we actually want to send this data towards? And of course, the payload is again event payload mapping key. So basically the exact same thing. So if I wanted to use statistics as the key, then the payload would of course also need to be of the type statistics so that everything is working just fine. And now just to make sure that our naming is coherent, we just rename this into IPC main handle, and this is IPC web contents send, just so we always know what's happening under the hood, because this thing wraps IPC main.handle and this thing wraps web contents.send. So now let's just head over to our resource manager where we are currently pulling our data, because if you remember, this thing runs main window.webcontents.send. And now we can just replace this with IPC web contents send. And the second parameter will of course need to be main window.webcontents. And now we of course also need to import it from util. And okay, we are seeing some issues right here. What's going on? Type unknown is not assignable to number. Okay, that's interesting. All right, so the problem isn't actually that IPC web content send is not type safe. The problem actually is that get CPU usage, so our little wrapper that we wrote around osutils.cpu usage, doesn't actually know what type it returns. Because right now it returns a promise unknown, which is of course not what we want. We actually want a promise number. So what we can essentially just do right here is force the return type, because we know what it is. So let's just say this is a promise number. And now all the types are safe. We basically just wrap this little library. So this shouldn't really be an issue. And if it is, then we'll find out shortly. So yeah, we've basically now both made sending data and handling events on the Electron side type safe. So next up is of course our preload script, so basically our UI, to also make the other side type safe. And then the full process between backend and frontend will be completely type safe, so that we don't have to worry about any of this anymore. And we can essentially just add new events by adding them to the event payload mapping. So now let's get into actually using this stuff on our frontend. And of course, remember, all of our front-end Electron stuff happens inside the preload script, because we want to expose as little of Electron as possible to the front-end. So basically in our preload script, we can now define more IPC wrapper functions. These need to be defined inside of the preload script, not inside of the utils function, because unfortunately, because of the way that Electron-Builder handles all of this, we can't import the util file inside of our preload script, because remember, all of these extensions right here, a CTS file, will not be able to import the TS file and vice versa. So we'll basically define these functions in here. And now what we can basically say is I want an IPC invoke function that once again takes in this generic key, and it will return a promise with the payload mapping. Because remember, invoke is async, so it will need to return a promise of the mapping instead of just the normal type. Because every time we're using it, we need to await the backend's response, basically. It's basically just like a fetch request, which is also always async. And then on the other side, we of course got APC on, which is basically used for polling or static data, if you remember. And here we've also got the key as a generic, and then we're gonna say our callback that basically gets executed every time the backend sends data will of course send a payload, and that payload will have the type event payload mapping with the key. So again, for statistics, that's going to be our statistics object. And then we're basically just wrapping electron.ipcrenderer.on with our key. We are basically discarding the event for now. And then our payload, which is normally any, will just be passed to our typesafe callback. And now if we just use these up here, so basically ipcrenderer.on will now just be IPC on with the statistics object. And the event right here will be removed, just so everything becomes even more type safe. And of course, get static data will also be IPC invoke get static data. And now all of this is fully type safe. If I change anything about anything, basically, so for example, if I now head into my type definition again, so into the types.ts file, and set this thing returns null right here, then we can also already see the preload script becomes corrupted because promise static data is not assignable to promise null. Because in our window, we define what get static data should have as a type. So basically, this little types.ts file now is a contract between our frontend and our backend that will always make sure that all our types are completely correct. So now let's just fix this up again by saying this is static data. And now all of our contracts work. And as long as we never use IPC directly, but only use the adapters that we've predefined, everything should be fully type safe from one side to the other. And of course, because we basically only wrote wrapper functions now, everything should also still work just fine, which is just awesome. So now let's finally get into actually validating events so that nobody can send any malicious data, which might even have wrong types, which would be even worse. So let's get into that. But what data do we actually have to validate something? Well, as I mentioned before, we've got this event right here. That's basically a parameter to any handler on function that we're running either on the backend or the frontend. But of course, given that we basically only need to really validate on the backend right now, we're only going to do it here. And what our event actually has is something called event dot, and you can see the sender frame. And from the sender frame, we can basically get some information about what location somebody is currently in their browser to basically verify that our code sent the event. So basically what URL is currently opened in the Electron process that is sending this event. And as you might remember, our current URL, if we're in a production environment, is basically this. So our dist react folder /index.html. And of course, we need to now verify that this is our current location that we're accessing the files from. So to do this, we are basically now going to go ahead and generalize this a bit by heading back into our path resolver that we've created previously and saying export function get UI path. And here we're going to return path.join app.getAppPath /distReact index.html. And now if we just head back into here, we can of course use this over here and import it. And of course, we want to return this from getUIPath. So now we've basically generalized our UiPath, and we could now, inside of a util function, check that event.senderFrame.url is equal to getUIPath, right? Well, not quite. This is where it gets complicated because once again, we are using a different URL in a dev environment than in our build environment. Because remember, on development, we are actually talking against our Vite server instead of the local file. So we basically need to differentiate here to make sure that it works both on the dev environment and on the production environment. And for that, we'll just copy over some code that I've previously created and go over what it does, because this will simplify the process by quite a bit. and it is also reusable. For this, we'll need to, first of all, also import something, which is the path to file function from URL. So what do I actually do here? Well, first of all, I will check if we're in the dev environment. And if we're in the dev environment, then I'm basically checking that the URL, frame.url, is under the domain localhost 5123, which should be the port we've defined previously inside of a vite config right here. So this is the case. And I'm basically wrapping the frame URL inside of a URL object and then getting the host attribute from it, just so I can basically only get localhost 5123 without the path, without the HTTP bit in front, just the domain, which is basically all we need to test on development, because if we're running on this port, then we can make sure that everything is just fine. And then the next step is to say, if we are not on dev, so if we're basically in the production build, then we need to check, is our frame URL not path to file? Gonna get into that shortly. Get UI path. So basically we're getting our UI path once again. Remember, this is path.join, app.get app path, this React index HTML. And what we basically need to do here is say, I need this URL globally. So not like slash dist react slash this slash that. I need to actually get this as a file URL on my system with file : / etc. And I need to turn this into a string just so I can compare it to the string that is webframe main.url. And now the important part is, if these two don't match up, so if my request came from something that is not my UI file, so not my index.html essentially, then I need to throw a new error, because this is a malicious event that's coming from some malicious site that was opened up in whatever way we might be able to imagine. And of course, this is not a foolproof solution. If you have multiple files in your Electron app, then this will of course not work. If you have, for example, a renderer in your Electron app that renders different paths, so basically a client-side router, then you will need to do something like checking if URL starts with this and then just ignore the rest of the path, or do more complex checks right here. This validate event frame method can become really complicated over time, because validation is always complicated, right? This is just a really simple way of validating by basically going ahead and saying, okay, is my frame URL something other than my index.html file that gets generated whenever I build my React app? And if so, please throw an error and don't let the event through. This is not a foolproof solution, obviously, but it is a starting point for you to basically build upon, so that you know how to validate events and how to prevent somebody malicious from entering inside of your system, which you probably don't want. So to now actually use this, we can now just say, I want to validate my event frame by going in here and saying, before I actually handle this event, I can just say validate event frame event center frame. And because we've already generalized the IPC main handle function, this is actually everything we need to do. Because now whenever we run IPC main handle, the event will already be validated. Which is also why we're doing this now and not a few steps before, because a few steps before we didn't actually generalize this, so it would have been more stuff we need to copy over. And now it's already generalized, and every IPC main.handle function will always validate frames. Alright, so now let's actually test this out. And for debugging purposes, I will just console log the frame URL, just so you can actually understand what is happening right here. So we'll open up the app, go into developer tools, and because we didn't actually call this in any part of our app yet, we are just going to go window.electron. And then we're going to get the static data. And as you can see, the URL is currently http localhost 5123. And if we just scroll up to where I did my call, we can see it's a pending promise, because again, every handle event is async. And now let's just go ahead, scroll all the way down again and await it, just so we can make sure that we actually get the data that we want. And we did actually make a little mistake, because we of course need to return the value from our handler. And because I added these parentheses inside of a callback, we of course don't automatically return anymore. So by just adding this return handler function real quick, we should now see that if I open it up once again and target developer tools, we should now see our static data right here. So now let's also test that our validation is still working by changing this to 5125. So basically we're now checking that the URL is not the one that we actually want. And we should see an error pop up if we now try to actually get this data. And we can see error invoking remote method gets static data, error malicious event. So we're basically now limiting the amount of access we've got to our Electron backend, which is always nice for security purposes. So now let's also test out the production build. And as you can see, the production build is also still working just fine, because as I mentioned, the URL is of course correct here as well. So our event validation on a basic level is now working, and you can now extend it to whatever level you want in case your app becomes more complicated than mine currently is. So now let's get to the final eventing part for now, which is gonna be unsubscribing from events to prevent them from piling up on the front end. And luckily, unsubscribing is really simple to implement. But why do we actually need it? Well, if you've ever done something inside of a use effect, like for example a set interval or something, then you might have realized that if you don't stop this interval, then every re-renders for every change to the dependency array will create a new interval. So in our case, this isn't really an issue because our dependency array is empty, right? But let's say that we are calling this inside of a component that can get unmounted. So basically, when the component doesn't render anymore, we of course also don't want to do any state updates because that might cause null pointers or just unexpected behavior. Because when you update state of a component doesn't exist anymore, that's really not something we are intending to do, right? So basically what we can do here is say, when this use effect stops, so when this component re-renders or unmounts, we want to unsubscribe from this statistics thing right here. And for that, we will of course need to return some kind of a function. So a common pattern is to do something like const unsub equals window electron subscribe statistics. And right now unsub has a type of void, so we can't really use it. So let's fix it up by first of all defining a type for that. So type unsubscribe function. And an unsubscribe function has a really simple type. It's a function that doesn't take in any parameters and doesn't return anything. So it's basically just a side effect function. And what we're going to do is our subscribe statistics function will just need to return an unsubscribe function. And now we can already see that our preload script now throws an error because we don't return anything. So we'll return the return value from IPC on, and IPC on also doesn't return anything. So let's change that as well. And luckily, electron.ipcrenderer.on also has another version of it, which is called electron.ipcrenderer.off. And this basically takes in the same parameters, and as soon as the key is the same and the reference to the function is the same, it will basically unsubscribe from a previous subscription. But this means that we can't actually do this right now, because these are two separate functions, right? We are creating a function up here and we're creating one more down here. So we need to define the function on top. So our CB, our callback, is going to look like this. This is going to be of the type Electron IPC render event. And our payload is going to have an any type because remember, everything inside of our adapters is typed with any anyway. So now we can basically say Electron IPC renderer on is going to take in this callback and off is also going to take in this callback. But we of course don't want to subscribe and immediately unsubscribe. So we're going to turn this into a function that you can call to unsubscribe from our Electron process. And we're going to return this function from our IPC on function. So basically what's happening now is if somebody calls IPC on, then IPC on will return the unsubscribe function. So another way we could write this is basically this right here, return the parentheses, return the return. And now we basically directly return the result of IPC on, which again is our unsubscribe function. So now if we head back to our app, we can see that unsub now is an unsubscribe function right here. And we can just say when the use effect is done, we are going to return unsub. Because if you return a function from the use effect, then it will either run when the dependencies change or when a component unmounts. So basically, if it isn't rendered anymore. And now we're basically already cleaning up after ourselves every time that we don't need the data or the event listener anymore. So we're saving on unintended consequences of multiple event listeners, and we're saving some memories so there won't be as many memory leaks, only the other ones we might implement later on, which we hopefully won't do. Alright, so now we can finally get into developing our UI, and as you can see, I've already prepared a bit because we're going to use the library recharts, which you're going to get by running npm install recharts, so like this basically. And because I don't want to go all that deep into setting up the graph we are seeing right here, I'm just going to explain what it does, and then as soon as we've gone over how recharts works and how we're going to use it, we can then actually get into filling this chart with our actual data to then display the data in the UI in a really nice looking way. And as you can see, I've done something really simple right here, just so you can see what I'm explaining. We've got this base chart right here that I set up, and we're just basically passing a few data points in there, so 25, 30, and 100, which you can see right here. It's a really slight slope in the beginning, and then it goes basically exponential when going to the value 100. So let's just take a little quick look at what I've set up here, just so you understand what the code does, and then we'll move on. So first of all, we've got an area chart right here. An area chart is basically a chart with a line that's got a filled-in area underneath it, just so it looks as nice as possible. Then we pass our data in there. That's basically just an array of objects that have a key called value. This value is defined right here. So if we were to rename this to something else, then our data right here would also need to have another key. But because I think value is a really nice key, we're going to use that. Then we've got, first of all, this Cartesian grid right here. And the Cartesian grid is basically this little grid that you can see behind the chart. So if I went ahead and, for example, said I want this in FFF, then you can see that it now becomes a lot different, a lot lighter. But I think 333 looks really nice. So basically using this thing, we can control what this grid looks like. It's just for a bit of a visual kick, basically. We don't really need it, but I think it's quite awesome. Then we define what our actual area and line look like. So in this case, we want the fill of the area to be slightly transparent. So you can see the line behind it. So it has a transparency of 0.3. If we were to set this to 1, for example, then we would see that you can't see anything behind it. But I think 0.3 looks really nice. Then we define the color of this background. Then we define the color of the line, how thick the line should be, what type of line it should be. So should it be a straight line? Should it be smoothed out a bit? All that stuff. Then we again define the data key that I've talked about before. So just calling it value. And returning of animations, because I think the animations are a bit over the top with this library. And for our use case, we just really don't need it anyway, because we're trying to recreate the Windows Task Manager in many ways, which also isn't really animated anyways. Then we define our x-axis, which we're defining with a height of 0 because we don't want it to be visible. And we're also defining a stroke to be transparent, just so we also don't see any line at the bottom right here. If you didn't set the height, then even though we set everything as transparent, it would still take up space, which we also don't want. So we're basically just setting the height of the x-axis to 0 and the width of the y-axis. And then we're also saying that it should start off at 0 and go to a maximum of 100, which is of course the case because we are displaying percentages right here. So we can't have a utilization less than 0. And we of course want our maximum utilization to be 100%. Which you can see really nicely here. The line ends at the top because the highest value our passed through is 100 and the lowest value that we can display is of course 0. And then we've basically got this area chart that contains all of this data and a responsive container, which is basically just used so that our chart knows what size it should have. And in this case, we are just setting its width and height to 100% so that we can externally control the height using a div. So this thing will only work when put inside a div. So if we just remove this right here, then it will behave quite weird because it doesn't know what size it should have. So it always needs to be inside of a div with a fixed height. Making this responsive is really hard, honestly. So you will need to tinker a bit if you want to use this library in a responsive manner. But in our case, that's not really the case. So when we're actually using this chart, we can just set some certain values for the height of the bounding box. So basically the div that this thing will be inside of. And then we can just use it in any way or form that we like. And now that we've gone over how this grid will work, let's actually now put our data from the Electron backend into the grid so that we can finally get rid of this basic UI that we've always been looking at and actually get our updated values from the Electron backend inside of this awesome UI. And first of all, of course, remove this little bit I've created right here so that our app basically has no differences now whatsoever. It's basically just the same as your app should be. And the only difference we've got now are the base chart that I've created that we've just gone over. And of course, the installation of recharts using npm recharts. So let's now get going by actually implementing our Electron data into this grid. And to do that, we'll first of all need to actually now get our data inside of our React state, because right now we're using a use effect to subscribe and unsubscribe from our data, but we're only console.logging it and not storing it anywhere. So to do that, we'll create a new file called useStatistics.ts. And in here, we'll now define a custom hook that will do this for us. And we'll, of course, export it so that we can use it elsewhere. And for now, we can basically copy over the use effect we already have and import that real quick. And now we, of course, don't want to console.log this. What we want to do instead is define some state to house it. So use state. And a use state is actually going to be an array of statistics, because we, of course, don't just want to display the statistics at one point in time. We want a range of data points that we're going to define as a parameter to this hook. So basically, we're going to say data point count, and that's going to be a number. And what this will do is we'll basically say, I want at max this amount of data points to be displayed in my grid or in whatever use case I'm having. And we'll take care of basically preserving this many data points. And if we go over or under, then we'll basically either need to pad the end so that the data points match up. Or if we go over, then we'll of course need to remove the earlier bits so that the newest bits still only are at position 10, for example, if you only want 10 data points. So now we can say value and set value right here, because this is a custom hook. We don't really need an awesome name. And we of course want to now return value. So the return value of this thing is now a statistics array, which we can also define right here just to make sure that we are doing everything right inside of this hook. And now instead of going console.log right here, we of course need to set value. And we of course need the previous value to be able to update our current value. So the simplest solution would of course be to now say we want all of the previous values plus the new stats like this. But now we didn't really use the data point count, because right now, if we, for example, say we only want 10 data points and we already have 10, we would add 11 and 12 and 13 at the end and not really clear up after ourselves. So the easy solution we're going to have for this is say const new data equals this, and then we're going to return new data from our set function right here. So we can now access the previous data inside of this callback, and the return value will of course be the new data that is actually being set. And what we can do in here is say if new data.length is bigger than our data point count, then we'll just say new data.shift. And if we just take a look at what shift does, it removes the first element of an array. So basically, as soon as we get over the data point count, we'll just remove the first item, so the one that we got at the start of the app running. And then when the next item comes in, we'll basically remove the second one, and so on and so on and so on, so that at most we'll always have data point count of items. And this is basically just the hook we're going to use for this. So now we can basically get rid of this real quick and try it out by saying const statistics equals use statistics. And now we can just add a data point count. I'll just say we only want 10 values. And we'll just console.log this. So let's just go npm run dev real quick. And we should see that we're now logging this to our console. So toggle developer tools. And here we can see the array becomes longer every time the polling takes place. And at 10, we're stopping because we're basically always replacing the first item with the second and so on. And the last item will be our new one. So now we've got an array that basically portrays an amount of time that has passed. So this is going to be really awesome for our visualization in our graph. So now let's actually get this into the graph by also defining a new function for that in a new component. So new file, we're going to call this chart.tsx, and it's of course going to build up on our base chart. We'll of course need some props, but those are going to come shortly. And here we're just going to return a base chart, of course. And the base chart only has one property, which is called data. So what we're going to need to do here is, of course, manipulate our data so that it fits. And right now, if we just take another look at our statistics real quick, which are right here, we can see this is a variety of different numbers. And let's say we want a chart that only visualizes our CPU usage. So what we've basically got is going to be an array of numbers, because we got an array of statistics. For each statistic, we're going to get the number of CPU usage. And this way, we basically have an array of numbers, which each represent the CPU usage. So let's just get into our app and implement it real quick so that we can work with it. So const CPU usages equals use memo to basically optimize on performance. And this use memo is gonna go ahead and say statistics.map. And for each stat, we of course want stat.cpu usage. Now let's just add the dependency array. We want this to refresh whenever the statistics change. And now we've got a number array. So let's just try adding this chart already, including a div of course, because as you saw before, we actually need this div with some kind of a height, which I'm just gonna do using inline styles real quick. We're gonna fix it shortly. And now we'll just add this little chart right here. And now we need our props. So export type chart props. And we of course need data. And our data is just gonna be a number array. So let's now put props.data in here and say our props are of type chart props. So let's take a look. Type number is not assignable to type value number undefined. Okay, so that's something we're going to need to work with, but this conversion will take place inside of this chart. So let's first of all now go ahead and say data equals CPU usages. And the next step is of course to convert our data. So we need some kind of way to manipulate this. And the easiest way is actually to go ahead and memorize this as well. So const prepared data is equal to use memo, because whenever we want to manipulate state into something else, we basically use memo. And in here we can now say props.data.map. And we of course want each data point, so point, to be converted into an object that looks like this. So value has the value of point. And now we of course need the dependency array in here, which is of course props.data. So whenever our props.data change, we want to update this. And now we can pass the prepared data into a base chart, and we should see that it's now working just fine. So let's just npm run dev once more, and we should now see our chart popping up, hopefully. And as you can see, we've got this data right here, and it visualizes something, but it's really, really tiny. And that's because our data is currently in a range between 0 and 1, but our chart is in a range between 0 and 100. So the easiest way to solve this right now is to just go ahead and convert this into percentages by going point times 100. Then we'll just open up our Electron app real quick by hitting npm run dev again. And now we should see our data points actually popping up on here. And we can see there's a really slight wiggle in there because my CPU usage is of course changing because I'm running a recording, this app is taking place, all that stuff. And yeah, that's actually working already. So that's really nice. But as you might have been able to see, if we just restart, the grid looks kind of awful in the beginning because we add one data point, then two, then three, and it becomes wider, which isn't really what we want. So let's just go ahead and also add max data points as another parameter to our chart and just say const points equals this. And we of course need to return the points again. And now we can say if these points don't have the right length. So if points.length is less than props.maxDataPoints, then we can just append more data points in the end. Or another solution for that, which is even simpler, is actually just going ahead and saying, I want to spread my points, and then I want to spread an array dot from. And then we say the length of the array that I want to add to the end is actually props.maxDataPoints minus points.length. So basically we are creating an array at the end right here. And the length of this new array, that's basically just a whole lot of undefineds, is gonna be the length that is missing from our points. So if we want 10 points, but we only have 5, then we add an array of another 5 in the end. So we now got an array of length 10. But of course, this thing will now complain because value, number, or undefined is not assignable to type unknown because it just doesn't know what type this thing has. So we'll just map all of these new items. And for each item, we'll just go ahead and say value is undefined. So now what we've basically done is gone ahead and created the missing amount of items for our array to have max data points of length and set the value for this piece of data point is undefined. Now we of course also need to say props.maxDataPoints is part of our dependency array because it might change. It probably shouldn't, but it might. And now we'll just go into our chart and say max data points is of course 10. We'll restart our Electron app, and now we should see that it looks a lot better. So the first point pops up here, and then all the other points go over, flowing to the right, and as soon as every point is there, we have this really nice flowing graph, which is exactly what we want. And of course, changing this up is really simple as well, because I'll just do it in a crappy way. If we, for example, want our RAM usage to show up, we can now just go ahead, replace this with RAM usage, of course also rename some stuff, and then we see our RAM usage popping up here, which is basically pinned at 100% right now because I got a Mac with 8 GB of RAM. I'm recording something, I have Electron open, I have VS Code open, I also have some other stuff open in the background. So yeah, I'm basically always using the swap file. So this thing is full when it comes to memory. But you can see where I'm coming from. And yeah, we're now basically properly using our Electron data inside of our frontend, which I think is really cool. And it's even reusable. So if we wanted another graph somewhere else, we could just use the useStatistics hook again to get the data, and everything would be properly functional, which is exactly what we want. So this is of course a really big achievement already, but there's something that you might have realized when debugging all of this, especially because we're still console logging stuff, which is actually not really necessary. So let's just get rid of this console log real quick. But if you did look into the console, then you might have seen Electron security warning, insecure content security policy. So this is going to be the next thing we are going to look at now, because we of course don't want any security issues in our app. And the security policy is actually something quite interesting that we can now look at to make our app even more secure against foreign entities trying to somehow inject data inside of our app. Again, this is not really an issue with our kind of app, but somebody like the developer of Discord, of course, needs to put a lot of effort into security. So we'll, of course, still look into how to make everything as secure as possible. And trust me, insecure content security policy can be a big issue for many apps as soon as you have some kind of XSS vulnerability. So let's look into now actually solving this issue as good as we possibly can. Let's go. So what exactly is this insecure content security policy? Well, you can see that Electron actually has their own section in the security section about content security policies. And they recommend that it be enabled for any site loaded inside Electron. And that is because it's able to restrict what kind of data can be loaded by your app. So if your index.html file in our case restricts Electron from only doing requests to certain websites, any cross-site scripting vulnerability your site may have is limited by what it can send data to. So let's say, for example, somebody malicious gets inside of the UI of another user and they want to send some data about that user to their server. Well, if you prohibit the UI from communicating with that server or loading scripts from that server, then you're already quite a bit safer. So let's just look at this little example right here. Here we've got somebody that basically just wants this message to be gone by basically saying my content security policy is everybody can do anything. And here we've got one that is labeled as good, which says my script source is self and https apis example.com. So basically anything on the domain I'm currently on, so basically in our case the index.html or localhost 5123 can do scripts. So I can load scripts from these URLs and of course also this APIs directory because maybe there's a script we need as well. But I couldn't do a script from, let's say, Google, for example. So I've prepared a little example right here as well, which is how you would do this inside of an HTML file. So we create a meta tag, and this meta tag has an HTTP equivalent. So this basically, if this was an HTTP header, what would it be called? And in this case, we are setting a content security policy. And the content is my default source. So basically for any type of value I want to fetch, so an image, a script, whatever, I first of all only allow myself to be the source. So I only accept images, CSS, scripts, etc. from myself. Then I say, okay, styles I also only accept from myself, but I will allow the UI to use inline styles. So basically I will allow my JavaScript code to define styles. I will allow inline styles in the HTML, which is not by default activated for some security reasons. But especially when doing something with React, oftentimes you will want unsafe inline to be enabled just so you have more options of using JavaScript in your code. And then of course for scripts, you can say something like self, and maybe you embedded Google Analytics, then you would of course also want to enable scripts from analytics.google.com so that Google script text can also be loaded and then send some data about your user to Google, which in our case is of course not needed. For debugging, you can also set the HTTP equivalent to Content Security Policy Report Only, because this is of course really restrictive. And if you already created your app and now try to set this header, then some restrictions might get into effect that cause your site to misbehave. Like for example, you didn't set unsafe inline in here and now your CSS doesn't load, which would be really devastating. Well, by setting your reports to report only, all of the issues will not be prohibited, but you will get logs in the console about what policy restrictions actually would have taken effect if you were to enable them. So basically, what scripts did load that should have not been able to be loaded. So for debugging purposes, you can just add this report only, look in the console, and if anything is logged by this policy, then you can know that your policy is too restrictive and that you need to change something about it. So in our case, let's just take this little meta tag right here and actually add it to our app by heading inside of the index.html, of course. And now inside of our head, we can just add this meta tag. Of course, we can just remove this analytics.google.com because we don't add any Google Analytics here. And now our app should still be working just fine. And this warning should now not load anymore, which is already quite the benefit. You still see some other errors in here because recharts didn't really do all the improvements we need for newer React versions that are coming up, but I'm sure at some point they will, so these errors are only a temporary thing. So now let's try to actually break this by making a policy that's more restrictive. For example, we remove this unsafe inline bit right here. So basically we now only allow CSS files that don't do any inline styling. And we can see we definitely do need this inline styling because this basically just broke everything. React uses inline styling for some of its stuff. So we actually do need to enable this. And now by doing that, we do of course see that everything is still working. And the same thing of course goes if we, for example, set script source is not self, but nothing, or maybe just google.com, for example, I don't know. If we now try that, then we can see no script is loading at all. So yeah, we are not fetching anything from google.com. Of course, it's not loading. We only want to accept scripts from ourselves to be sure that no external malicious scripts can be injected into our app. And now I may need a few reloads. I don't know. Let's just close the app and open it again. And then we should see that everything is working properly. And by now actually committing this meta tag right here, we are now also safe about our content security policy, which is another great step towards a more secure app. Even though, as I already mentioned a few times, for our app, this isn't really as necessary, but for many apps it is. So let's just add it anyway, so that if you try to build anything based on this tutorial, you have a good starting point that you can build all of your security up upon. Now we could, theoretically at least, already finish our app. We've got a front end, a back end that communicate in a type-safe manner, and we also already got all the information that we need. But of course, that's not everything I want to show you. I also want to show you features like hiding items to the system tray. So basically, when you close the window, it doesn't just close the app, it basically just pauses it and hides it in the system tray. So we of course need to add an icon to the system tray to do that. And before we are now going to start implementing this, we're first of all going to need to go over some requirements for defining an icon. So I've actually defined two icons right here, and we're going to go into the Windows one real quick. So as you can see, this is a colorful icon that I've just defined so that the contrast is really good on Windows. And if we just look at its info real quick, we can see it's 16 by 16 pixels. And that's not because I just thought I didn't really need much resolution. That's the default icon size for Electron. So both of these icons are 16 by 16 pixels. But of course, you might want to have more resolution to create something like this VLC media player icon right here, which of course does use more than 16 by 16 pixels. And to do that, you can actually add extensions to your icon name. So this right here is my current icon name, icon.png. And if you just added add2x to your icon name, then Electron would know, okay, this is not 16 by 16, this is 32 by 32. Or 4x would be 64 by 64. And this way you can basically define bigger resolutions in your icons and still let Electron know what resolution to actually use. Electron unfortunately doesn't just read the resolution of the image and scale it appropriately. So if we were to use a really large icon in here, then it would just overflow and basically get cut off at the tray. So you'd have a really, really awful looking icon because it would use it as if it were 32 by 32 pixels and not scale anything, which is of course not ideal. So if you want to create a large icon, please remember to just add the add 2x, 4x, 5x, whatever to the end of your icon name. And you might have already seen that my other icon, which I'm going to use on macOS, is called tray icon template. And template is actually the same thing. So you can add template to the end of your icon to turn it into a template image. But this will only work on macOS. And template images have a few other requirements. They can only consist of black and alpha channel pixels. So basically a PNG that has a transparent background. If you just take a look at this, then you can see the background of these pixels is transparent and all pixels are completely pure black. So 0R, 0B, and 0G. And yeah, that's basically how you define a tray icon that's a template icon. But what does it actually do? Well, if you just take a look at these macOS icons, you can see they are basically always black and white. And that's because there's actually a built-in feature in macOS that will change the color of your icons depending on the background color. So right now I've got a really dark desktop background, which means that this bar up here is black. And therefore I of course want all my icons to be white. So what tray icon template will basically do is Electron will replace all the black pixels with white ones if the background is dark, so that there's a really good contrast. And the same thing of course goes for a light background or a white background, where you're basically still keeping all the black pixels. So this icon right here from the VLC Media Player will turn black if I use the VLC Media Player on a light background. And the same thing is something that we want, of course, as well. So Electron actually offers us this feature if we just call the icon template in the end. And of course, you can still combine this with all the other features for DPI density, so larger images, by just calling it icon name template add to x.png. And this way you can basically define large icons that are still consistent on macOS because they change color if you need them to. This is a lot of theory about just defining an icon, but it will allow you to create a really good looking icon on any operating system. So basically on Windows, I'd always recommend using a bit of color to really have all the contrast that you need, because Electron just doesn't really offer any template feature on Windows. And on Mac, you just use a template feature because it gives you a really coherent and good looking icon. So now that we've gone over this theory, let's actually get into using my two icons in our Electron app so that we can actually implement a height to tray functionality. Let's go. And of course, first of all, we need to now tell Electron where our asset files, so our tray icons, actually are, because Electron-Builder will need to know that it needs to include these files in the final app. And I added these files under source assets, and then I've got my two PNGs right here. So we can just head into the electron-builder.json file, and here under our extra resources, so basically everything that is not code, we can now just go ahead and say I want to add source/assets/***. So basically in a recursive way, add every folder and every file that is under the assets directory into the final bundle. And now we can already go ahead and actually define a little function in our path resolver to actually access these asset files. So let's just add this little function right here. We've got this get asset path, and we're of course joining the app path again. On dev, we stay in the directory we are. On production, we go up one directory as we are with everything else basically. You can see the same pattern up here. And then we're just going source/assets. And now we can actually already use this in our main.ts to now create the tray. So we're just going to create a new tray, which we can import from Electron. And this tray actually just takes one parameter, which is the tray icon. So now we can just say get asset path. And we of course need to append what path we want. So we need another path.join to make it work cross-platform. And here we can now just join tray icon.png. We're going to implement the differentiation between Mac and Windows shortly, but for now let's just try this out so that we can see if the colorful tray icon now pops up on the top right here. And we can now actually see that the icon is popping up here, but of course we are now using the colorful icon that we want to use on Windows and Linux, and not the black and white one, so the template icon from macOS. So let's change that up so that it is coherent with all the other icons we've got there as well. And to do that, we actually just need to do one simple little thing, which is to check if process.platform is equal to Darwin. So basically when we're on macOS, I want to display one icon, and when we're on Windows or Linux or basically whatever other platform there is, then I want to use the other one. So if we are on Darwin, so macOS, I want to use the tray icon template.png, and if I'm on Windows, then I want to use tray icon.png. So now let's just restart real quick, and we should now see the correct icon popping up here, which it actually does. So we've got that handled, and that's actually a great achievement already, right? We can now actually control which icon we want to show. So let's just switch that real quick just to make sure that everything is also working the other way around. So if I were to say that only Windows has the black and white icon, then we can now see the colorful one. Absolutely perfect. And of course, we also want to test the proper template functionality. So let me just npm run dev again and open up the system settings to now change my desktop background to something light, so that we can also see that the template icons react responsively to the changing of the background color. So as you can see right now, I've got this space wallpaper. So something that's basically as dark as possible close to the top. So let's just switch to a solid color like this one. And now we can see that the icons all become black because the background is light. So that's basically the purpose of using template icons, because they respond to changes right here. And if I now had an icon that was only white, for example, then it would of course look terrible on this really light background. So what do we do now? Well, right now we've got a tray, and we of course want a hide tray functionality. And for that to work, we need to somehow enable Electron to say, when I close all windows, I don't want to stop the whole app. I want to still have the tray icon and be able to basically click on it to open the app back up. And right now, if I just close this window right here, we're going to see the tray icon also disappears because the whole Electron process stops. So our next step before actually implementing more of the tray will now be to basically go into how Electron handles closing windows to better understand how we can basically implement a hide to tray functionality. And of course, the easiest way to first of all try to implement this hide to tray functionality is basically to tell Electron to not do its default behavior when all windows are closed. So basically, when I close the window, please don't stop the app. And to do that, we'll first of all try to go ahead and say main window.on, and I want to listen to the close event. And I want to say, when I close the app, I will basically get an event, and I will say event.prevent-default. So basically, when you get the event to close the window, just prevent your default behavior and do nothing. And even though this sounds really great, if we just try it out, we're going to see it doesn't really work the way we expect it to. Because now I actually can't close the app at all. And it's not even just that, we actually can't quit the app using quit Electron cursor up here either, because that will actually go ahead, try to close all windows and then quit the app. And if it can't close all windows, then Electron will just give up. So right now we can only close it using Control-C in the terminal right here. So what events will we actually need to use here? Well, it's a bit complicated, so let's get into some more theory right here. And to now understand this, we first of all need to get into how Electron knows when to actually close. And there are multiple ways to close an Electron app. First of all, the one we want to prevent, which is closing all windows. If we close all windows and didn't implement anything, then Electron will just quit. Then there's of course the way of calling app.quit, which will first of all try to quit the app, then close all windows, and when that was successful, then the app will actually terminate, which is basically what we saw when we hit close Electron codes. And lastly, there's the automatic way. So there are features in Electron, like for example an auto updater, that will basically, when you start the app, check is there an update, and if there is, then it will directly close the app, install the update, and restart the app. This is not going to be something we're going to tackle in this course, but it is of course a feature we need to keep in mind so that we don't break it. And functionally, it's basically the same as app.quit. Because if we just take a look at the event order, then we're going to see that depending on what reason Electron uses to close itself, the event order will be different. So if we close all windows, then first of all, we're of course going to get the event that the window is closed. Then a before quit event will be triggered, which basically tells us that Electron is about to quit if everything is successful, and then the app will actually stop. But if way 2 or 3 happen, so basically if the app is quit directly or automatically, then the before quit event will happen first. Then Electron will try to clean up everything by basically closing all windows. And if that is successful, then the app will stop. So basically what we need to do is check, did the before quit event happen before my main window.close event happened? And if so, then actually close the window and stop the app. But if my window.close event happened first, and then the before quit event happens, then I don't want to quit the app, because then the before quit event only happened because I did close the window. So basically check if the before quit event happened first, and if so, close the app. If not, then prevent the app from close. And that's going to be exactly what we're going to implement now, so that you can actually understand what I'm talking about here, and so that we can get into a simple but still a bit complex way of how Electron handles events and how event order can change depending on how the event was created. So let's get into it. And to do all of this cleanly, we're first of all going to now define a function, which is going to be called handle close events, which is going to need our main window, which is a browser window. And we're actually going to do all of this inside of this function just so it's a bit cleaner. And of course, to now persist what events happened at what point in time, we also need some kind of a variable to do all of this. And we're just going to call it let will close equals false, because by default, we don't want the app to close. Before we now move on, let's actually just use this app right here and call this function using our main window and actually implement the hide to tray functionality in a way where we actually hide the window. Because right now, if we just try this out again, then we're going to see that the window doesn't close, but it also doesn't get hidden away or whatever. So to do that, we're actually going to call one more function, which is mainWindow.hide. And mainWindow.hide will actually do everything we need on Windows and Linux, but not quite everything on macOS. So let's try this out using npm run dev. And if we now do this and click on the X, then you're going to see the window is gone, the try icon is still there, so the app is still running, and the taskbar item is also still there, which we probably don't want to happen. Remember, this only happens on macOS. On Windows and Linux, you probably don't see a taskbar icon. And that is because there actually is a variable on the app that you only set on macOS. So we can now say if app.doc. So basically, if there's a doc property on our app that is basically responsible for handling the macOS doc, then we want to call app.doc.hide as well. We basically just need to do this if check to make sure that hide actually exists so that we don't get any null pointers. And if we now try this out, once again using npm run dev, then we can now see that our hiding functionality is actually working. So let's click onto this. Then we can see there is no taskbar item for Electron anymore, but the tray icon is still there. So now that we've got that properly set up, let's actually get into our will close functionality. And of course, the easiest thing we can do for now is say, okay, if I do actually want my app to close, then all of the functionality we just built is basically irrelevant. So we'll basically just add a return statement early before any of this happens. So basically we don't print anything, we don't hide anything, we just let Electron do its thing if will close is true. So now when do we actually set will close to true and when do we set it to false? Well, we talked about this before quit event previously. So let's just add that. There's actually an event on the app because, well, it runs before the app quits and it doesn't really have anything to do with the window directly. So here we can now say when before quit is run, we just say will close is equal to true. So basically, if close happens first and before quit happens after that, then will close will be false for this if clause, the default will be prevented, and will close will just be set to true afterwards, but nobody listens for it. So this is fine. And of course, if before quit ran first, then this will be true. The default will not be prevented and Electron will just do its thing and close the app. So everything is fine here. But let's just say we hide the window and then we show it again. Well, now will close is actually true. And independently of how I close the window, the app will close. So that's not something we want. So we also need to reset this value when a window gets shown again. So basically when we click on the tray icon and tell it to open our window back up. And there's also a function for that, which is called mainWindow.onShow. So basically every time we want to show our main window, we just reset this variable by saying will close is equal to false. So now let's just try this out, right? Let's just hit npm run dev right here. And the easiest thing we can do now is actually just go ahead, hit on Electron right here and say quit Electron course. So basically directly calling app.quit. And you can see the tray icon is gone, the app is gone. So we actually directly quit the app, which is the same as the auto updater doing this or us directly calling app.quit. So now let's try the opposite by now closing our window and seeing that the app doesn't quit. So I'll just click this right here. We can see the tray icon is still there. There's no doc icon because we called app.doc.hide. And now we can, of course, just not close the app in any way or form whatsoever because we didn't implement this yet. So the next step will, of course, be to now implement that so that our hide to tray functionality actually still allows us to close the app and, of course, also to open the window back up again because right now it's just lost, honestly. And to get started, we're first of all going to take our tray right here and move it into a separate file just so all of our concerns are a bit more separated. So to do that, let's first of all create a file called tray.ts and create a function in here called export function create tray. This will need a reference to our window, which we're going to use later on. So let's do that already. Main window, browser window, just so we always have access to everything. Because remember, we need to show our window when we click on the tray. So of course we need to reference it somehow. And now we can just take this new tray method right here and put it inside of here. We'll fix that up shortly, but first of all, we're going to now create tray inside of our main function again, just where we created a tray before. Pass our main window, and then we can just import everything we need in here. And now let's just hit npm run dev, and we should see that our tray is now still popping up, but it is put into a separate file for convenience sake. So now we can actually reference our tray by saying const tray equals the new tray. And then we can say tray.set context menu. So basically the menu that pops up when you click on the tray. And this context menu will now take menu, which is another import, .build from template. And in here, we now put an array of options that we want to be clickable. So to get started, we'll just add one option with a label called quit. And when we click, so the next parameter is called click, we will call this callback, which just runs app.quit. So now we do, of course, need to import app in here, which isn't currently imported. So let's quick fix that. Remove the semicolon. And now we should already be able to close our app from the context menu. So let's just try that out real quick by hitting npm run dev again, waiting a few seconds. And now we can see that there is a quit option right here. And if we hit that, then our app closes because of the handle close functionality we implemented before. Let's try it the other way around as well, where we now close our window first so that we basically minimize it to the tray. And if we now hit quit, then we just see the context menu disappear and our app is of course still closed. Perfect. So of course we also need a show functionality now because we also want to be able to show our window again when we hit it to the tray. So to do that, we'll just add another label right here called show in a new object. Add the comma so that everything is still working. And then for our click, we're going to do multiple things. First of all, we're going to need to do main window.show. And if we do that, then we should already have something working on Windows and on Linux. So let's just try that out real quick. And we should see that I can now hide it to the tray. Everything is also gone down here. And now if I hit show, we can see the window is back, but our dock icon is still gone, which we probably don't want. So for macOS functionality, we of course also need to say if app.dock. So if we're on a system that supports the dock, then we of course want to say app.dock.show as well, so that that will also pop up again. Now let's just hit npm run dev one last time. We'll hide it, we'll show it again. Now we see that the item is in the dock again, and we can also quit the app by clicking right on here. So this is basically the whole tray functionality we're going to need. The most important part is of course the functionality of when to close the app, when not to close the app. Actually setting the context items is pretty simple. And there are even more things you can do with context, like you can add submenus and stuff by setting a type basically. And this type has multiple options. You could add a checkbox in here that you could read out of. You could say it's just normal, so basically the thing we've got right now, a button basically. You could turn it into a radio button where you can read the state out of it. You could just add a separator for the app to look nicer, or you could also add a submenu, so basically you would have a menu inside of your context menu to add more options under a specific headline. For example, let's say you have a functionality that switches views, you might have switch view as a headline and then all the views underneath it. But of course, for our use case, we are going to do that in a different way of implementation. So we just need a show and a quit functionality, which we've now implemented. What we are going to do now is actually stay with this menu.build from template functionality, because we're actually going to create a custom menu for it. So basically that's going to be what you see up here on the left on macOS, or directly under your frame where you also close the app on Windows. So let's take a look at how we can actually create custom menu items for that as well. And luckily, creating a custom menu is actually quite similar to creating a tray menu. So to get started, we're first of all going to move this into a new file again. So menu.ts, and this is going to export a function called create menu, which for now is not going to take in any parameters. And here we can now call menu from Electron once again, dot set application menu. So basically the menu of our whole application and not of a specific window. And in here we can now, just like with the other menu, just say build from template and pass the array of things we want inside of it. But here we're now going to get to the big difference between the application menu and the tray menu. Because if we just compare VS Code, for example, we can see we've got a lot of different menus right here with sub-menus. So basically for a tray, we basically just defined one layer of items and that's it. And here we're going to always need a menu, first of all, that will contain a submenu, because otherwise our actions will not work properly. So to get started, we'll first of all create an object with a label called app. So label right here is going to be app, and the type is going to be submenu. And now we can just define a submenu in here like this. And the submenu is basically the same as a normal menu. So now we can add options in here, like for example, saying I want a label called quit. And then we'll basically do the same thing as before. So if we click on it, then we're just going to call app.quit like this. Now let's just import the app real quick by importing it from Electron. And now we should be able to actually add this thing to Electron and see that it is working. So let's try this out by actually calling create menu right here without any parameters for now and hitting npm run dev once again. And then we should see that our menu is now popping up on the top left. And we can see it's actually called Electron and it's not called app. But you will not see this if you are testing this on Linux or Windows. But let's first of all take a look at if it works. So let's just hit quit right here and we can see it does work. So why does it behave differently on macOS? Well, macOS has a default behavior of basically limiting you to your first item always having the name of your app. That's just default behavior, and we can only get around this by using some hacky workarounds. For example, if you really didn't like this, then you could go ahead and basically just add another item in the front right here with a label called placeholder, for example, or just an empty space, I don't really care. And then setting the visible property, which we haven't really used before, to false. So basically, this is going to be an empty item that we're always going to hide. If we now just reload this real quick, then we're going to see that this first item is disappearing, so the one that was called Electron previously, and we now only see the app. So this is a workaround that you can use, but I really don't recommend it because it can break in future updates. For example, you basically add custom behavior for one platform that isn't really told to be for that platform, so you can't really see that from the code. I really wouldn't recommend it, and as I said, it's default behavior for the first item to have a different name. So a much better way would be something like process.platform equals Darwin, ? Then don't set a name at all and just leave macOS to set the name itself, and otherwise call it app. So on Windows and Linux, it's now going to be called app, and on Darwin, it's just going to take the default name. And independently of any Electron or macOS updates, you will always have the default macOS behavior in here, and Electron won't overwrite anything. So this is actually the way that I'd recommend of handling this, especially because you will probably add some basic functionality like quitting the app in here anyway. So that's an awesome feature to just add to the initial option. And then you can just add a second option right here, which you might call something like view, for example, where you can then be able to change the view. So we could say something like, I have a view for the CPU. We'll just remove the click for now because the functionality will actually be implemented afterwards. Then I'll have one for the RAM and of course one for the storage right here. And now if we just retry this again, then we can see that we now got two items in here, one of which being Electron. If I just get it to work properly, sometimes the highlighting doesn't really work and you don't get the menu. That's just Electron things basically behaving not the way they should, but just the way they do. And now we can see we've got Electron up here, and then we've got our view with CPU, RAM, and storage. And of course, the quit functionality on our Electron bit still works. But now what we've done is we've actually gotten rid of the functionality to open up the dev tools, which we were able to do previously. So let's also implement that again, but also in a slightly different way, because you probably don't want your production users to be able to access them. So we are going to implement a custom functionality where those dev tools are only accessible in dev mode. So on click, we will now need the main window. So main window is of type browser window. And we'll just pass it through real quick. So main window. And then on click, we can now just call a function that runs main window dot web contents dot, and then we should have something like open DevTools. And if we now call this, then our DevTools should open up in the main window, and we should be able to still access everything the way we did previously. So let's just try this out real quick, and then we should see that everything is still working properly. Let's just hit show here again, and now we're going to call DevTools right here, and our DevTools are going to open up. But of course, we also need the visible feature, which I already showed you, and we just say this is only visible in dev mode. So now if I just try to build my app and run it real quick, then we're going to see that this is now called Electron course, because as long as we're not in dev mode, this is going to be the actual name of our app, while in dev mode, it's just going to be called Electron, at least on macOS. And we can see that we now only got the quit functionality while running in dev will allow us to actually see the DevTools and access them, which is probably what you want because you might not want your users to just tinker around in your app as much as possible. So enabling the DevTools only in dev mode does make sense, of course. But I did of course promise you to also show you how to disable the menu completely. So let's just do that real quick as well by enabling this create menu bit right here. And then you need to do this following bit outside of the app.onReady function, because for some reason it will only really work if you do it before the app is initialized. Afterwards, you will have to do some more tinkering to actually disable the menu, because Electron will already have initialized it and the setting it to null bit will not work properly. So outside of app.onReady, we'll just call menu.setApplicationMenu again and just set it to null. And if we now try this out, hitting npm run dev again, then we're going to see that our menu is now reduced to the absolute minimum. So on macOS, that will be basically just our quit bit right here. So you can still close the app, but nothing else. And on Windows or Linux, you will basically not have an application menu at all, which is also probably what you want. So that's just a little workaround for basically disabling this menu. But in most cases, you might at least want some basic functionality in the menu. So I wouldn't really recommend completely disabling it anyway, especially because you probably at least want your DevTools to work in dev mode. So you might at least want to call this conditionally or something. But anyway, this is essentially how you can set a custom application menu. We are now going to comment this in down here again, of course. And then our next step after importing again is of course going to be to now actually add the functionality for our CPU, RAM and storage view change again. But this will need some IPC communication, so this is going to be our next step to now set up a communication to basically tell the frontend to switch between the CPU stats, the RAM stats and the storage stats in the basic UI. And of course, because we've already set up a lot of IPC helpers, this is actually quite easy to do. So we're going to define a click functionality for a CPU real quick. And here we can now just go ahead and say IPC web contents send. In here, we're now going to need to define an event. So let's just get into our types real quick and define our new event as well. So first of all, we need to define a payload. This is just going to be a type called view, and view will be CPU or RAM or storage, just like in any other location where we're using these values. And then we can just define a new event. So change view is going to be our event name. And of course the payload will be a view. And now we'll just add it to the window by basically allowing the frontend to subscribe to the change view event. So subscribe change view could be a good name. Then the type is of course going to be view. The parameter is going to be called view. And it will of course, just like any other function, return an unsubscribe function. All right. Now we can see our menu right here. We can now define what event we want. We of course want a change view event. Then we need to reference our web contents. Our main one is already the parameter here, so we can just pass that through. And then our payload will of course be the word CPU. Now let's just do the same thing for RAM and storage as well by just copying over these names at the end right here. And now we are already sending the events. But of course we also need to receive them. And if you just take a little look at our preload script, we should see that it now throws an error because we didn't subscribe to the change view event in here. So let's just do that real quick by hitting this and saying subscribe change view. And then we of course need to listen to change view in here. And now all the types are complete. So we can just hit into our front end and actually try to subscribe right here. app.tsx. And in here, we'll just add a little use effect. And in here, we can now call window.electron.subscribe change view. And here we'll just add a callback that for now console.logs the view. So let's just do that real quick, calling this over here view. And of course, adding our dependency array, which doesn't contain any dependencies. We'll just return the return value of subscribe change view, which of course is the unsubscribe function itself. So the cleanup will be done automatically this way. And now if we just try this out, we should see that when we click on change view, something should be logged to our console. So let's just try that out real quick. And now we'll just hit storage over here and we can see our value is being received on the front end. So now let's actually implement everything we need so that our frontend will actually update the current view so that we no longer see the CPU statistics, but for example, the storage or RAM. So let's just copy all of this a few times, call this RAM usage, and the variable is going to be RAM usages, and then storage usage and storage usages. So what we're going to do now is define a useState, const active view, set active view equals useState. And in here, we can now just say this is of type view, and the initial value will be CPU. So when you open up the UI, it's always going to be on the CPU. And now we'll just add a use memo const active usages is equal to use memo for optimization's sake. And then we'll actually implement our memo. And of course, we need a dependency array. And in here, we're now just going to implement a switch case for our different values of active view. And now we can just say, in the case that it's CPU, I want to return CPU usages. And now we'll just copy this for all the other cases. And we need to add all of these to the dependency array so they update nicely as well. So now let's just add all of this in here. And then we should be able to actually just pass our active usages in here to our chart. And if we now just restart real quick by hitting npm run dev once again, we should now see that we're able to switch our views just like we'd expect ourselves to be able to. And I did of course forget to update my use effect here, because when the view changes, we of course now want to set the active view instead of just console logging it. So let's just try again by restarting our app. And now we should be able to see that our view will update over here. So let's just fix this up by actually seeing the correct menu up here. And then we'll just click on RAM and we see that this thing is updating real nice. So next up, after now going into two native features, so the tray and the menu, we'll actually go away a bit from native features, because we'll now basically remove the whole frame from our window so that we can have a window that's see-through, or just a custom window that has a custom frame, like VS Code, for example, which doesn't use the default Mac frame, because we've got this search bar up here. So let's just play around with this a bit right now. And creating custom window frames is actually an awesome way of showing how Electron sometimes uses really tiny features to basically still enable full functionality whilst customizing the app as much as possible. Because we do of course need our window to still be draggable, for example, even though we removed the normal window frame from the system and implemented our own one. But before we get into that, let's first of all actually get to removing our frame. So if we just first of all hit our app up with npm run dev, then we're going to see we have this default frame around here, right? On macOS we have these items on the left, on Windows we'll have them on the right, we've got a title, all that, and we're basically going to get rid of all of it. Do remember though that on Windows and Linux, this will most of the time also get rid of the menu. So if you do want a menu, then you either need to re-implement it completely yourself, or you will need to use the default frame, unfortunately. But anyway, we will now get into actually removing the frame, which is really simple. When initializing our window, so the main window creation basically, we can pass a parameter called frame and just set it to false. So that is a really simple way of actually completely disabling the frame. But now we are really limited. We can't move this window. We can still resize it, but we can't close it. We can basically not do anything at all. So we can still quit the app, of course. So that's nice. But we do need to now create our own frame so that we're still able to interact with the window at all. So to do that, we'll actually head into our UI right now, and I will copy over some code because, yeah, just defining some CSS isn't really as interesting. We will go over what it does though. First of all, we will just add a header into our app that will contain 3 buttons, one to close, one to minimize, and one to maximize, just like with any other normal app. And this will be inside of a header just so we can easily style it, and because it's basically the header of the app, right? The menu bar or the frame is essentially the header. And then we can basically just head into our CSS right here and now style it. You could now remove all of the default CSS. We're going to do that later on though, when we actually try to make our UI look pretty. For now, we'll basically just add some more CSS on top of here and clean it up later. So what we're going to do is basically first of all style our header. So basically the header is going to be positioned at the top because all of the default styling really shouldn't apply. We don't want to center it or whatever. That would be really unnecessary right now. So we position it absolutely on the top, right at the edge of the screen with a full width. We'll give it some padding and set its box sizing to border box just so it doesn't overflow the screen. Then we'll text align it to the left so that all the buttons are left centered, because I'm on a Mac. If you wanted to build for Windows, then you might want to text align to the right. And we're going to set a nice looking background color. So let's just try this out real quick by hitting npm run dev. And you're going to see what I'm really doing here. So you can see I've basically now got a dark bar right here with a few buttons inside of it. And of course, we also want to style these buttons now. So let me just copy over some more stuff, because this is actually, first of all, going to need to style our buttons all at once. So basically every button is first of all going to remove all the default styling, It's going to be round, it's going to have a width and height of 1 rem and a margin so that they're spaced a bit. And then I've basically just colored all the buttons with nice looking colors, similar to the macOS colors, just so they can be differentiated. If we just take another look, we can now see here are our buttons. And yeah, if we click them right now, then nothing happens because we didn't add any on-click functionality. But anyway, these are now at least here, and we can then later go ahead and actually implement this functionality. But for now, the interesting part now will be, how do we actually tell Electron that this is our header and we want to drag the app when we drag this header? Well, this is actually really simple as well. We just need one property, which is the WebKit app region. If we just add this to our header right here, so dash WebKit app region is drag, then we can now drag our app using the header. So this now enables us to still drag and drop the app. And if you now say, for example, that you don't want to be able to drag on these buttons because, well, you want to press them and not accidentally start dragging the window when you actually want to close it, you can just copy this over, add it to your buttons, and just say the WebKit app region for this is no drag. So basically now we can't drag on the buttons. So we will just click them, but if we drag on this bar, then it is still possible to drag the whole window. And this is basically what I mean when I say that Electron will enable you to still have a few really tiny UI features that are Electron specific to basically give you the full functionality of a normal app, even when you try to override some of the default Electron behaviors, like for example, hiding the frame. And also there's one more piece of information that you might want to know about. Because if we just try to enable our frame now by setting frame to true, then you will realize that Electron will actually take some power away from you, because now we can only drag the window on top right here and our WebKit app region will actually not work anymore. So that's just something to keep in mind. You can't really use this in any window that does have a frame. Now let's get into actually enabling our IPC communication so that these buttons will also work. And the interesting part about this event is actually that we now send data from the front end to the back end without actually expecting anything in return. We basically just let the front end tell the back end, hey, I want to maximize, minimize, or close the window, and you just do your thing. I don't care if you respond. So before we now actually implement this, we of course first of all need a new type in our mapping right here, which is just going to be a frame window action. So either close, maximize, or minimize. And then we need this in our payload mapping. So here we can now say send frame action, and our frame action will just be a frame window action. And of course we also need something on our window right here, which is just going to be called send frame action. And that's just going to be a function that sends a payload in the form of a frame window action. And now we of course need to implement all of the bits to actually make this work. So our preload script is already read because we didn't implement the send method yet. So let's just do that real quick. Send frame action takes in a payload, and then it needs to do something with it, which we didn't implement yet. Because we need some way to actually run a send event from the frontend, because right now we can only invoke and on in the frontend and not send. So let's just copy the IPC on real quick. We don't need a callback, we just need a payload right here. So we can get rid of this bit, call this IPC send. All of the other stuff with the generics of course stays the same. Then we don't need a callback, we don't need a return statement. We can now just go ahead and say IPC renderer.send key with our payload. And now we've basically already implemented a typesafe send wrapper. And now we can just go up here where we right now aren't doing anything with our payload. And then we can just say IPC send with our send frame action and of course the payload. And now everything is typed properly because of a type file, which already says that this is a frame window action. So now let's actually already go into our app right here and give all of these buttons their proper actions. So on click, I want my close button to of course go ahead and say window.electron.send frame action. And here I want to pass close. And of course want to do the same thing for the other buttons as well. And now the front is actually already done. So we just need a listener on the back end to actually now implement our functionality. And for that, we'll just head back to our main.ts file, and where we're currently doing IPC main handle, we can now do IPC main on, which doesn't exist yet. So let's implement it. IPC main handle will just be copied over here. And now we'll just call this IPC main on, and we'll of course need to implement everything. So we will not return anything from here. So it will return void, and we will need a payload in our handler, which is of course of type event payload mapping key, because we of course need to pass through our value. And now we will just call this handler with our payload. We will of course still validate the frame just so we don't do anything that we don't really want to do, so that the sources are always correct. And now we can just go ahead and say the handler is forwarding the payload. The event is already right. We can just rename this to on instead of handle. And now we've got an IPC main on listener right here. And now we can just import the new method and actually add all the missing parameters. So first of all, we got the send frame action, and then we need a listener with the payload. And here we can now just really easily go ahead, do a switch case for our payload, and just execute different commands depending on what payload we got. So let's say our first case is close. In this case, that's the easiest one. We can just call main window.close. This will then trigger all of our close logic down here. So it's basically the same thing as if you were to click on the actual close icon on the window, if it were to exist without a frame. And then we can just break. Next up, we need to do the same thing for maximize, which will actually call really similar code. It's going to be main window.maximize. And the same thing, of course, goes for the minimize function, which will also just call main window.minimize. And now we can basically try this out, and we should see that all of these buttons should now do what they expected to do. So the minimize button minimizes something, the maximize button maximizes, and the close button closes it without actually quitting the app, because it of course runs into our custom handle close events function down here, which is basically exactly what we want. So now we've got a few different IPC events, some sending the data from the front end to the back end, some going the other way around, and some doing an actual full communication from front end to back end and back. So these are basically the main versions of communicating in Electron, which we've now all handled. And as you can see, Electron actually offers a lot of custom functionalities. We can create a tray, we can create custom menus, we can get rid of the default functionality at all, basically, by just removing the default macOS, Windows, or Linux frame and just building our own. We can actually really tap into a lot of functionalities. And we didn't really go into nearly all of them. You could of course also use some system default uploading or downloading functionality for files, etc. All of these features are of course really well documented in the Electron docs, and we don't really have the time to go through all of them because that would take forever, and of course new features are added regularly. So what we're going to do now is actually go away from looking into all the specific features of Electron and go into how you can actually test an Electron app, because that's not as simple as you might think it is. So let's look into that. But of course, before we can actually get into writing our tests, we first of all need to take a look at what different types of tests we can actually write. And of course, for that, we first of all got unit tests, component tests, and end-to-end tests. These are the main three types of front-end or full-stack code tests. And of course, we can now go through all of them and check if they make sense for our app. So first of all, we got end-to-end test. So basically completely starting up the app and running tests inside of it. This is basically the main way we are going to focus on writing tests, because we of course want to test the integration of a UI inside of Electron and also test some of Electron's features. So having a full end-to-end testability basically that allows us to really test all the Electron features in combination with the UI is of course the best for this course and also for many functionalities that involve Electron. And two of the main libraries you could use for end-to-end test are Cypress and Playwright. Cypress though doesn't really offer a functionality for Electron embeds right now, so basically for really opening up an Electron app and maybe even showing multiple windows. Playwright though does actually allow you to start everything up in an Electron context, where you can actually open up the window and do some special Electron side code actually. So we're going to use Playwright here. Then we've got component tests. As you can see, these can also be written in Cypress or Playwright, or with testing library in a unit test kind of way. We are actually not going to focus on these. For one, because when you're using Cypress or Playwright, the code is actually basically the same that you're writing. You just mentioned that you want to render a component. And also, as the name suggests, you're basically mainly testing front-end code. And as we want to test our Electron code right here, this really doesn't make sense for our situation, even though you could of course use it if you build a full app with complex components that you want to test. And lastly, we've got unit test, which you could write in Jest, vtest, Mocha, whatever. And these can be used on the front end or the back end. We're of course going to focus on the backend, especially on features that we can't test in end-to-end tests, because our Playwright end-to-end test library for Electron doesn't support all the features that Electron offers, like for example our tray. So these are basically the decisions we're making. We're using vtest for unit tests for features that can't be tested using end-to-end tests. We're using end-to-end tests for general functionality of our app, and we are not using component tests because those are primarily used for complex UI features, which we don't really have and don't want to test right here. So let's start off by now writing a little end-to-end test to really get started and finding out how all of this really works. But of course, before we can actually get into writing any tests, we first of all need to set up Playwright and configure it to work with Electron and Vite. And to start off, we first of all need to run the installation wizard for Playwright using npm init playwright. And this will basically ask us where we want to put our test files. I'll just call the folder E2E, so end-to-end, because we will have unit tests and I don't want to get anything confused here. Then it will ask us if we want to set up GitHub Actions. The default is actually no here, and we will not get into GitHub Actions in this course anyway, so we will stay with saying no. And lastly, it wants to install the default browsers, so Firefox, Chromium, and Safari. For our use case though, we basically only need Chromium for Electron, and honestly not even that, but some browser needs to be installed for all of this to work properly, so we will just go with Chromium. So we will say no, and then we can just go ahead and run npx playwright install Chromium, which for me will happen instantly because I've already installed it, but for you it might take up some time because it will install up to 100 megabytes, which is also why we aren't installing any other browsers because it's a waste of resources. And now we've basically got this end-to-end folder right here and also the test examples. Test examples are basically just an example of what syntax you can use, but because we'll implement everything ourselves, we can actually directly delete these. And now we can actually already head into a package.json and add a new script called test end-to-end, or whatever you want to call it. And here we'll just call playwright test to basically run the default test, which will just go to playwright.dev and check some default settings of the Playwright side. So now if we just run npm run test end-to-end, we should see that we are now running the tests and that everything is working just fine. But we are actually getting 4 errors right here, which is because it tries to run the tests in Firefox, WebKit, and Chromium. So basically each test in here, each of the 2, runs once in Firefox, once in WebKit, and once in Chromium. So how do we fix this? We only got one browser installed. Well, we head into the Playwright config right here, and here we can see projects. So basically, for what browsers do I want to run my tests? Well, I basically don't need any of these browsers, but as I mentioned, it won't run properly if you don't have any browser set up. So we'll stay with using Chromium, and then we'll just remove Firefox and WebKit. So you could comment this out or basically just remove it completely. And now if we just start test again, we should see that it passes with 2 green tests. So now we can actually just do one more thing, which is connect this to our Vite instance. Because if you remember, what we're doing when we're starting our dev environment is we are spinning up the Vite server, we are spinning up the Electron app, and the Electron app connects to a Vite server to basically allow hot module reloading. And this is also what we're going to do when using this app. We're basically spinning up the app in development mode and then telling it, hey, you basically now need to connect to the Vite server, because we of course don't want to build the app every time we want to run a test. So what we'll need to do is basically tell Playwright, okay, you spin up the Electron app, but before you do this, please run the web server that the Electron app will need to connect to. And to do that, we'll basically comment in this web server bit right here. Then we'll need to tell it what command runs the web server. So if we just take a little look right here, that's npm run dev react, which will basically just run Vite. So let's just put that here. And then in our Vite config, we can actually go ahead and see the port, which is 5123. So let's paste this and try it out. And what we're actually going to see is that it won't work. It will basically never do anything, because it will now wait for the Vite server to start up, and it will only run any tests if the server actually started up successfully, which it unfortunately did, but we don't see this here. So what it actually does is it tries to get to this URL. And if you now try to open this URL, then it won't work, which is the case because Vite actually expects you to use localhost and not this IP address. We could configure Vite to use it, but it doesn't really make any sense for us. So we can just rename this to localhost 5123, quit the script and run it again. And now we can see that the test should start up again perfectly. And the Vite server actually starts up in the background, which is exactly what we need for Electron app to be running perfectly as soon as we get to actually implementing it now. So let's go. And of course, before we can actually run an Electron test, we first of all need to initialize our Electron app and the main window before every test. And luckily there's a helper for that called test.beforeEach in Playwright. And here we can just pass an async function that should execute every time before a test runs. And here we can now use another little helper from Playwright, which is called _electron, which will allow us to interact with the Electron app. And to start off, we'll first of all launch Electron using certain arguments. So as you can see, we first of all pass the arguments, which is dot, and we pass an environment. The environment is of course our node environment, which we're saying to develop, just like in our package.json, and this dot is actually the same thing we're doing in our package.json as well. So if we just take another look in it, then we'll see that when we run npm run dev electron, we first of all, of course, build Electron, then we set the environment to develop, just like we did on our launch script, and then we just run Electron with a dot to basically tell us, hey, our Electron app is in this directory, please run it right here. And that's basically the same thing we're doing here as well. And then we can just do one more thing, which is await Electron app.first window. And by doing this, we're basically now waiting for Electron to open the main window to then start the tests. So if we now just go ahead and run npm run tests end to end, we should see that our tests now open up this window real quick before then closing, because the normal tests run through and everything is fine. Now you do also see that I've got these check marks right here and this play button, and these will actually allow me to run tests separately from each other, which is really handy as well. And you can get that by actually installing the extension playwright test for VS Code. I think this is really helpful and it might make debugging a lot easier for you as well. So I would recommend that you install it, but that's just a little hint on the side. So now let's actually get back to our tests, because we also need to clean up after ourselves. Because every time we run a test, it will now open up an Electron app and not really stop it properly, which might cause memory issues. So what we'll do here is basically clean up after ourselves using test.aftereach. We'll pass another async function, and then we'll just await Electron app.close. But now our Electron app is of course not available, because it's only available inside of the before each. So the simple solution for that is of course to go ahead and say, let Electron app appear. And now all of this works, but our Electron app has an any type. And to solve that, we could now either try to import it, which is actually not as easy as you think, or we can just set this type to be the return type of the type of _electron.launch. And this will almost work, because we now get the return type of this launch function, but as you can see, we need to await it. So the launch function actually returns a promise. And to now convert this promise of an Electron application into an Electron application, we can now just go ahead and say, I want the awaited return type. And now this is basically of the type Electron application. And we can actually do the same thing for our main page as well, because of course, when we want to interact with our Electron app, we will run queries against this page. And to make that work, we of course need to get the page outside of the test before each as well. So to do that, we'll actually just do the same thing real quick. And as you can see, this is really similar. We just replaced electron.launch with electron app.first window. So basically building up on this type, we can now get this type and use the main page any way we want as well. And as you can see, our after each is now working perfectly as well, because it of course now can access the Electron app. So now let's get into actually writing some tests on our Electron app instead of on the HTTPS playwright.dev site. And to get started, we'll actually interact with the frame we've just built by clicking our custom minimize button in the UI. We first of all need to run a click event on a certain tag on our main page. And because we've given the tag the minimize ID, we can now just interact with this item by running main page.click with the hashtag minimize to get the tag with the minimize ID and click it. And of course, we also now need to find out if the app was actually minimized. So for that, we can actually run electron app.evaluate, which will basically give us an option to not only interact with the UI, but also with Electron internal code. And this is done by actually passing a callback with the Electron object right here, which we can now interact with. And to do that, we can basically now go ahead and say, okay, from my Electron app, I want to get the browser window APIs, and I want to get all the windows. And because we only have one main window, I want to get the first one and the is minimized value. And now I can just use this is minimized value outside of this evaluate block. The only thing you need to be careful with here is that this can only return JSON formatable stuff. So you can't pass something like a function here, and you can't pass something like a date. And now that we've done this, we can now use this is minimized function in an expect block. So we expect is minimized to be true after minimizing. And if we now just try this out by killing our terminal and running this again using npm run test end to end, we should see that the window opens. We even saw it minimize. And now if we just move this up a bit, we can see our test passed. So testing against our UI now works perfectly fine. Awesome. And of course, we can do something really similar to actually check Electron internal stuff as well. So here's a little test for checking if our menu is working. So first of all, we run electron.evaluate after a window has opened and basically just get our application menu that we've configured and get it as a variable out here. So this is now an Electron menu or null, but because we've set it up, we know it's not null. But just to make sure, we'll first of all check that it isn't null, and then we can get the items from our menu, which should be 2 items, get the sub items, count how many they are, and then we can run tests on our label. And as you might remember, our label is actually not called select, it is called view. So let's just change this up real quick. And now if we just run npm run test end-to-end again, we should see that our tests pass, right? Let's try this out. And we can see that our tests passed perfectly fine. But at some point you might realize that some of these tests are a bit flaky because sometimes they tend to like flicker a bit. So sometimes they are true, sometimes they are false. And that is the case because this electron-app.first window will actually check if our browser window was initialized, which is basically the first thing we're doing. We're not even loading a URL or whatever. We aren't doing any of this code down here. And many times we will actually not reach this create menu all the way down at the bottom. And to prevent this issue from ever happening, we can actually go ahead into this before each block and basically wait for a preload script to have been loaded. And after all of that, we'll be really sure that most of our Electron code will have at least loaded once, so we won't have all that flickering that will sometimes happen. In this case, we were lucky, but it will not always be this way. So let's get into implementing that. And luckily, this can be done in quite a simple function as well. So we'll create a function that will wait for our preload script to load. And because we'll basically poll for the preload script, we need to wrap this inside of a promise. Because as you can see, I'll create an interval that will run every 100 seconds. And when you want to await something in an interval, you'll basically need to create a new promise. And then once you've reached the desired value, we'll basically just resolve the promise so that your promise will not be awaited anymore, but actually return something. And what we'll do here is basically now just go ahead and say main page to the evaluate. So we will not go ahead and evaluate something in Electron, but actually run code inside of the HTML of our main window. And here we can basically now just go ahead and say, I want to get the window inside of my main page. Here we actually need to fake the type a bit because we can't use our global type that we define in the tsconfig because Playwright just doesn't use the tsconfig. And what we'll do here is basically just get our Electron object that is created using the preload script right here. And now using this Electron bit, we can basically go ahead and say, okay, I will save this as an Electron bridge. And if the Electron bridge was initialized, I want to stop the interval. So I will stop polling and resolve this promise so that I can stop awaiting it and actually move on with my test. So we'll basically go ahead and say, okay, every 100 milliseconds, I want to check, did the window now load the preload script and is my Electron object initialized? And if so, please stop polling and just resolve this promise with true so that we can move on. And by basically now doing this, we can just go ahead and put this inside of our before each block. And now the test should stop flickering. I can of course not show you really that this is now not flickering anymore, but you just need to trust me that this will make your test a lot more stable. And as you can see, it's still passing just fine and it will pass even better if your test didn't work because, as I mentioned, it can flicker sometimes. So for me, it just worked, but for you, it might not have worked the first time and it should work now. And this is basically everything you need to set up to test your Electron app using end-to-end test. You can now test your UI, you can test Electron-specific features, but you cannot test every Electron-specific feature because this Electron app.evaluate bit, this Electron thing can't access everything. It, for example, can't properly access a tray. So what we'll do now to actually test our tray menu is actually create a unit test using vtest that will test this tray menu and make sure that it works as well, so that you can also see how you would unit test your Electron apps. Let's go. And to now actually test our tray, we first of all need to set up vtest, which is going to be our unit testing library for this. And first of all, I'd of course recommend the VS Code extension again, just for better debuggability. And I'd of course also recommend that you install vtest using npmi safedev vtest. And after doing that, we should be able to get everything set up. And now that it's installed, we'll basically just need to add another script to our package.json as well, called test:unit. And this will just run vtest source, so that we basically just run every test in our source directory. And now we can already go ahead, go into the Electron directory and create a new file called tray.test.ts, which will now contain our tests for the tray. And in here we can now start off by importing some stuff from vtest, of course. And using this, we can now go ahead, define a name for our test and a callback function that should execute when we run the tests. And of course, the main thing we're going to do now is actually create a tray. So let's just import create tray from /tray. And this is now going to execute our tray creation. And of course, if this now were an end-to-end test, then we'd need to set up the app, pass the main window, and find some way to actually test stuff on the tray. But because we're writing a unit test here, we're now going to try to create a few mocks, as few as possible, of course, to basically turn off most of the Electron functionality, create a custom main window that only has the functions that we need, and basically just get us through so that we can get all of the data out of the tray that we need and run tests on that. And to get started, we of course need some kind of a main window right here, because create tray expects a main window to be passed. And if we just take a look at the implementation, we can see the main window is only used to run the show method. So we need some kind of an object that has a show method for our test to actually work. And we're just going to create one right here. So const main window, and show is going to be a vi.fn. And what this will basically do is we create a mock function where you can basically say, okay, this function should not do anything. We can test if the function was run. We can also go ahead and define custom behavior for this function. So it should have a custom return value. It should have a custom implementation. All of this stuff can be done in vtest, but for our use case, it is plenty to just be able to check, okay, was this function called? So did my implementation actually work? And now we can just pass this main window into create tray. And we're going to see, okay, there are still some type errors here because our main window is actually not of type browser window. So because this thing can't actually be cast to a browser window properly, we'll just say as any right here. And to still make sure that we have a good dev experience, we'll also say that it satisfies a partial of a browser window, which will allow us to still have good autocomplete, like for example, defining a hide function on here, which is basically inferred by knowing that this should be a partial browser window, so we can get all the highlighting of a normal browser window while still having the types of any basically. And if we now also want to know that this is a browser window down here, because right now I can't know that there's a show function on here, we can also just cast it to a browser window after casting it to any right here. And now our type is a bit ugly, but it will allow us to both have good autocomplete inside of this object and also outside of this object, because now main window.show is actually something that exists. And if we now just try this out real quick by going into our create tray function and just removing the default implementation real quick and just running main window.show, then we should be able to actually test that main window.show was called to make sure that everything is working properly. So let's go expect main window.show.to have been called. If we now just run this test using npm run test :unit, which we defined before, then we should be able to see that my test now passed. And if I now go ahead and just stop this show from running by hitting create tray and just commenting this out as well, then we see my test failed, which is exactly what we'd expect. So now let's actually reverse all of this by actually commenting all of this back in and getting to actually implementing all of the mocks we need for this to basically not actually try to run Electron code, but only run the code we need to get through here and basically interact with the menu that we create right here. Because what my goal for this test is to basically go ahead and check, do the functions, so the click functions inside of the show and the quit block actually do what I'd expect them to. So we need some kind of way to basically get into this menu.build from template function. So we'll basically mock it, get the parameters that we pass to it, and then run tests on these parameters. But of course, to do that, we'll first of all need to mock the tray, because if Electron will try to actually spin up an app to create a tray, then that will fail, because inside of the context of a unit test, we can't spin up an app. And then we of course also need to make sure that our mocked tray does actually have a set context menu function, because if that doesn't exist, then we'll run into a null pointer here. And once all of this works, we can basically mock menu.build from template and then get the parameter of this mock and interact with it inside of our tests. And luckily, vtest also has a really nice mocking library. So we just have vi.mock, and here we now pass the name of the library we want to mock. In this case, this is going to be Electron. And here we just pass in a function, and whatever this function returns will now be the stuff that is exported from Electron. So if we now just go ahead and pass an empty object here, then all of the imports in our tray will now not work, because we're basically telling Electron, no, you don't export a browser window or a menu or whatever, you export nothing. So we now need to go ahead and define everything that Electron should export. So if we just take a look at our implementation again, we can see, okay, we need a tray, and the tray needs to be a function, because a constructor is basically nothing else but a function, and this function needs to return a tray. So let's do that. Starting off with defining the tray right here. And because we want to have some custom implementation, we'll define this as a vi.fn. And this will have a mock return value. And basically, whatever we pass into this mock return value will now be what is returned when we call tray. And in this case, this should be an object. And if we just take another look at the implementation, this will then be the tray. And the only thing we run on the tray is actually set context menu. So our mock will need to have a set context menu method, which once again is just the vi.fn. And now we should almost be at a point where set context menu is called, but if you just take a look at our test right here and make this a little bit bigger, then we're going to see app.getAppPath doesn't exist because app isn't defined. And the implementation actually needs this app because it's passed as a parameter to a new tray. So we can't get to this set context menu function as long as this app isn't defined in getAssetPath right here. So we now need to define an app. and actually define the function that is used here, which is of course get app path. So let's also do that. So we'll just go ahead and say our app is an object, and this object has a get app path function, which is also a vi.fn with a mock return value of /. And now we can see that we're actually failing when we run menu.buildFromTemplate because the menu doesn't exist. So we at least got to the point where our tray.setContextMenu was now called. So let's actually get into also mocking this function so that we hopefully can now go through this whole thing without running into any errors. So let's just go in here and also define our menu. So menu is also going to be an object, and the only thing we call on it is buildFromTemplate. And again, buildFromTemplate is just the vi.fn. And now we see that our tests still fail, but this is not the case because we still expect main.show to have been called, which of course doesn't happen. So now let's just change this up real quick by now saying that we want menu.buildFromTemplate to have been called. And we of course need to quick fix this by actually importing menu from Electron. And now we can see it's waiting for file changes and it passed because this was actually called. So we can now run logic on it by basically checking, okay, what parameters were given to buildFromTemplate and what functions did I actually pass, and do these functions do what I expect them to. So let's get into that. And of course, to do this, we'll now need some kind of way to get all the calls that happened on buildFromTemplate, so all the parameters that were given. And this is really easy. We'll just say const calls equals menu.buildFromTemplate.mock. And now it says that mock doesn't exist. And that's the case because we actually can't tell the import to have a different type using this mock thing right here. So we basically need to override it. So let's just put some parentheses around here. If we now just go as any, then the error is of course resolved. But there's actually a better way, which is going as any, as mock, and then just importing mock from vtest. If we do that now, then we actually get this calls object right here. But this is now our whole mock context and not just the calls. So to solve that, we can just go .calls right here. And now we basically got all the calls that happened on this menu. And because we know that only one call happened, which is basically the one we see right here, we can basically now just go ahead and say const args equals calls 0. And to make sure that we also get good types on here, we can now just say this is an as of parameters type of menu.buildFromTemplate. So we can now actually know what the types of these arguments are, which is a template of electron.menuItemConstructor options or electron.menuItemArray. And by now using this, we can actually run some tests on the things we passed to the template. So let's just get rid of our current test and actually define a new one by getting the template, which is the first argument to our test, of course. And then we just expect the template to have a length of 2. So basically, first of all, the label show and the label quit. And if we now just save this, we can see our tests still pass because we do, of course, have a length of 2. And now we can get into actually implementing some logic as well by first of all going ahead and saying, okay, I want to get the first item of the template. I want to click on it. And then we just pass 3 nulls because if everything is removed, it will complain. Because by default, the click function in the menu will actually take some parameters. But as you can see in our implementation right here, we actually never use these parameters. But TypeScript still expects us to define them. So you can basically just pass 3 nulls as any right here, which cannot cause a null pointer because we actually never used them. So now just calling this click function right here should give us the exact behavior that we've implemented in here. So right now we should call main.window.show, and if an app.doc is defined, it should call app.doc.show. So let's just add a test right here by saying I expect main.window.show to have been called. And now we can see our tests are still passing. But of course, if I now do the same thing for our app.doc, which would also be interesting, we can now just go app.doc.show and actually import the app from Electron. Then we're going to see our tests now fail because app.doc doesn't actually exist because we didn't mock it right here. So let's just add that as well. So we'll just say the doc is now another object, which also have a show function, and that's going to be a vi.fn. And now we, of course, can read this vi.fn, check if it has been called. And of course, that is true. So we now also tested that. So lastly, we just need to check if the second button works. So if it actually runs app.quit. And for that, we once again need to go into here because quit is also not mocked yet. So let's just go ahead and say quit is also a mocked function. So once again, so that we can read if it was called. And now we just go ahead, go down here and run template 1. So the second item of our template, so the quit item, and just check that if we click that, we expect app.quit app.to have been called. And as you can see, our tests are still passing down here. And we can of course also do some simpler stuff, like for example, expecting template0.label to equal show, which will of course also pass because the first parameter we're passing to a template is of course the show function. And by now doing this, we've of course also set a really great example of how you can actually use vtest to test Electron functionalities in case you either can't test them using end-to-end test or don't want to test them using end-to-end test. So now we can actually finish this testing bit right here, because I think these are good methodologies for using tests in Electron. You can of course still do some UI tests as well, but those are not specific to Electron, so I won't go into them here. But what we will go into now is actually implementing our UI properly, because right now it looks quite ugly. So let's get into actually making it look nice to really finish up this project nicely. Let's go. But before we now move on to the UI, I'd first of all like to say that we're only going to be writing React code from now on. So we will of course still interact with all the Electron code we've written, but we won't write any new Electron code. So if you were only interested in Electron bits, then you're free to go now. I hope I could help you. I hope you'll check out more of free code camps and my stuff. But if you're also interested in seeing the final result of this course, then you're of course free to stick around as well. And we'll now get into actually developing this UI. And to make sure that you're always seeing what our changes actually do, we will now stay in the split view right here, where we basically are only working with the app.css, index.css and app.tsx. So we won't be creating new files for better structuring or whatever. We'll keep everything in these three files just so you have a better look into what we're actually doing, because having this bar on the side here would just take up too much space. So to now get started, let's first of all head into our app.css and actually get rid of all the styling that we didn't create ourselves. So basically anything but the header. So let's just remove this right here. And now if we save, we can already see, okay, all of the stuff is now put on the left right here, and we've lost a bit of our custom styling. Now let's do the same for the index.css, where we basically remove everything but this root bit right here, scroll all the way down and remove all of this. And now we can see we are almost at the right point. We're only seeing that our header is sticky right now, which is of course not ideal. So let's change that up real quick by removing this position absolute as well as the top and left property. And now if we just take another look, we can see it already looks a lot nicer, but we've got this little margin right here. So in our index.css, we'll also just go ahead and define the body to have a margin of 0. And now our app already looks quite pretty. Let's just get rid of all of this default React stuff right here by just throwing that away right here. And now we've got a blank slate that you can work with. Awesome. And because my goal is that we basically now got the child on the right and select for the CPU, the RAM and the storage on the left, we'll first of all create a little grid where we can put these things inside of. So we'll start off by going underneath the header and just adding a div right here that will basically wrap all of this. And then we'll add another div to basically have all left side content. And of course we'll need a class name for our grid now. So main grid, for example, just so we can get rid of these inline styles, which look kinda ugly right now. So let's just now go into our app.css and start defining some styles. So main grid will have a height of 120 pixels, just so it looks the same as it did before. And now we've basically got a lot better structure as well. And we'll just take this header right here and also move it into a separate component, just so everything looks a bit cleaner. So function header, and header will just return all of our header logic right here. So now let's just render the header right on top of this, and everything already looks a lot cleaner and it's easier to maintain as well. So let's just put a little class name main right here so that we can actually work with our content as well and start styling it. And also let's just put a 1, 2, 3 in here so you can actually see what we are doing. Heading back to our app.css, we'll just go in here and say .main. And main will be a display grid property, and we'll just define that the grid template columns are 24 rem and auto. So basically the left side will be 24 rems in size and the right side will just grow as much as possible. So if we just try to resize this real quick, we're going to see the right side grows, but the left side has a content width. You could of course also do something like fit content, but because we don't actually have any content yet, we'll just go with 24 rem as kind of a magic number. And now we can actually start defining our content in here. And for that, we'll actually create a new little function component, which is going to be a select option, because we of course want to select between the CPU, the RAM and the storage. So we'll structure this outside of here just so it's easier to work with. And it will of course return a little button actually, because it's going to be clickable, so a button does of course make sense. And we'll actually render multiple of those because we're going to have a CPU, a RAM and a storage button. And for now, we'll just put lorem ipsum in here just so these buttons have some content. And then actually remove the default styling because we of course don't want these ugly buttons. We actually want something that looks nice. So inside of our index.css, we'll also go ahead and say button all unset to basically remove all the default styling from our buttons. So now they're basically just normal inline elements. And this way we can now just go ahead and actually start implementing these buttons by doing something like defining a little title in here, for example, as another div. Then we're also going to add a little class name to these buttons to style them. So the class name is going to be select option. And we can start off by saying a select option should have a display property of block, just so it's basically just like a div and not an inline element. And we'll also add some padding to make it look nicer, so 0.5 rem. And now all of these are already structured a lot better. So let's move on by also defining some kind of a content. And what I'm thinking here is actually adding a little chart in there, just to basically always show the statistics of the selected option as well. And for that, we of course need to now actually add some data in here. So we'll just go with an empty array for now to make everything work. But of course, we will need to actually put some data in here shortly. And we also, of course, need some kind of a subtitle, because what I'm thinking here is having something like this says CPU. And then beside the CPU, we've got the title of the CPU. So something like i5 7500K, for example. And this should be next to each other, basically. And to do it, we'll of course need one wrapper to make it sit right beside each other. And now we can add all the class names to actually make this look nice. And from here on, we can now start styling. So let's just copy this over and say we've got a select option title and a select option chart. So let's start off by saying our chart has a height of 100 pixels, for example. And now we can already see it popping up here. And we of course also want it to take up as much space as possible. So it should have a width of 100%. And we still aren't seeing anything right here because this thing is display block, but it doesn't fill the space. So let's also give it a width of 100%. And now this already looks kind of nice, even though it's still a bit weird. So let's also style the title real quick by saying this is display flex. And now we're at least getting close to what I want. We'll also add a little bit of a distance between the two titles. So a gap of, let's say 1 rem. And now we're at least getting close. So you could see that this says CPU i5, this could say RAM and 8 gigabytes, and this could say storage and 500 gigabytes, for example. And then next to it, we've got our graph. But I think that we can go with a bit less space. So let's just go with 16 RAM right here, just so our graph is a bit more prominent. And of course, we also want a little gap in here. So let's just go with a gap of 1 rem, just so these things are spaced out a bit better. And maybe also make the charts a bit smaller. So how about 4 rem, just so they can basically show some data, but not as much as this right now. And just so everything looks a bit nicer as well, we can also go ahead and say our select option title has a first child. And that first child should have a font weight of, let's go with 600, just so the CPU title is a bit more prominent. And then the next child, so nth child 2, should have a font weight of 400 and a font size of 0.8 rem, just so it's not as big as well. And now we've already got a good setup. So before we actually continue on styling, we'll now of course need some props in here. And these props will of course now be the title, the subtitle, and our data for the chart. And having now said that, we can already see that these values are read properly. And we of course still need to actually get our static data in here, because right now all of these titles are to-dos, but we do of course already fetch them from Electron as a static data object. So now let's actually try to actually read this and write it inside of here. And of course, to get started with that, we'll first of all need to create a new function to actually get our static data. So use static data, and use static data will basically now just go ahead, define a use state to basically house our static data, or null if it hasn't been fetched yet. Then it will use a use effect to basically, first of all, get this static data somehow. So we'll define an async function that will await window.electron.get static data and directly write the result to a set static data function, so that we can now return static data from this hook and actually read our static data. So let's just try this out real quick by going all the way up here and saying const static data equals use static data. And now we can start using it to actually pass this as values to our select options. So for example, the subtitle for our CPU can now be static data.CPU model or an empty string as a placeholder as long as stuff hasn't loaded. And we can now see our CPU is Apple M1. And we can of course do the same for the other two as well, just so they look as awesome as this one does as well. So we'll just go with total memory in gigabytes to string, just to the types match. And for the storage, we'll of course do just the same. And now we can see this is an Apple M1, this is 8 and this is 245. And we do of course want to format this nicely. So let's add a few parentheses around here and actually just add a little string with space GB at the end. just so it's formatted a bit nicer, and do the same thing down here as well. And now we can already see that all of these pieces of information actually make all of this look a lot nicer. So let's just go ahead and actually improve our styling once more by just going into the styling for the select option. First of all, set a nice looking background color. I think 2C, 2C, 2C looks really nice. Then also add some margins so they aren't as close together. Also add some border radius because that never hurts. And lastly, also add a hover state so you can actually see when we're selecting something, and also add a little cursor pointer as well, just so we can see that we can actually click on this stuff. And as you can also see, our grid currently prevents this pointer from working, so we'll also need to do something against that. And actually the easiest solution to do that is to just go ahead and say for every child of our select option chart, we also want the cursor to be pointer. So now when we hover this, we actually can see that our cursor is now correct. And we now just need a click functionality so that we can basically control what chart should be displayed here. And luckily this is really easy because we've already implemented view changing, so we'll just need an on-click functionality right here that we can just pass to this button right here. So on-click on the button will of course just run props.onClick as well. So props.onClick. Then we just add the type to this button and actually implement our view changing up here. So on click, we just run set active view to CPU, and do the same for the other two as well. And having done this now, we can now just click onto these, and we can actually see that the chart on the right is updating depending on what we click on here. And by now just adjusting a few dials, like for example, changing the height of this little select option chart, and also setting all of this to be centered, and changing the height and padding of our main grid, we can now basically make all of this look a lot nicer already, and maybe just add a few little things right here, like for example, adding a bit of a margin to our main option right here, like for example 1 rem. So let's now just give it one more finishing touch by actually adding a custom color for each type of statistics so that you can differentiate them better, and then we're done. And because the color is actually currently defined right in our base chart, we basically now need to propagate it up. So let's just add a little fill and also a stroke as a string, pass this through and actually read it. So here we're just gonna now put in props.fill and props.stroke. So now let's just go one layer up into our chart where we'll now define our colors right here as a little color map with our little types of views as keys. So CPU, RAM and storage, and the colors we want as parameters. And then we'll just add another little prop right here, which is of course gonna be the selected view, which is also just gonna be CPU or RAM or storage. And now we can basically just go ahead and store our color as a use memo right here, and just go, I want the color map, and from the color map I want to get props.selectedView, and my dependencies will of course just be props.selectedView for this little hook right here. And now let's just pass this as a parameter. So of course the fill will be color.fill, the stroke will be color.stroke. And now we just need to go up one more layer and actually pass this into all of our charts right here. So here we'll of course go ahead and say selected view is gonna be our active view. And then here for our other chart, we'll just do the same thing. So our selected view is just gonna be props.title real quick. And this of course does work right now because the title are CPU, RAM and storage, and it actually looks really nice as well. So if we just click on storage now, it's going to be green, and if we click on RAM, it's going to be orange. So all of this is really nice, but of course the types are currently wrong because the title is of course not the right thing to use here. So we'll just go ahead and say view, which is going to be of type view. And now having done that, we can just pass view instead of title right here, and just go ahead and also say that our view is also going to be the string storage as well as RAM and CPU. Now you can of course see that we are repeating the word CPU 3 times right here, so there's a lot of optimization that could be done. But for our use case, this should be totally fine, and the only thing we could now think to do is to just add a little max width right here, because this looks a bit ridiculous. So let's just go back into our app.css, go into our main, and just say the max width is going to be 900 pixels, just so when we zoom it up, we're going to see that it looks a bit better. And then we'll just go ahead and say margin auto to hopefully make it centered. And now we've got a really nice looking little app. We could also add some margin top, for example, to basically fake a better looking app, like going with, I don't know, 4 RAM, for example. And now we've basically just got a little CPU monitor where we can change views. We can of course also change views from up here to now go to RAM. And all the colors change. All of this just looks really coherent, and I think this is a really nice makeover to make everything close up. It's of course still not perfect, but I'll leave you to basically style this in any way you want from this point on. But I think this is a great little result for this little course. And now that we're done, I'd like to once again thank you for sticking around, and I hope I could help you with your Electron journey and you're able to build a really cool project now. And I also hope that you're either going to check out some of my stuff and of course some of the awesome stuff right here on the FreeCodeCamp channel. And I also hope that you can have an awesome day. Goodbye.